Good evening, my dear JEE warriors. Welcome aboard. This is your captain Shreyas. How are you guys doing? And I hope you are all ready. Hello, Herborine. Hello, Subita. Hello, Dharnishwaran. Hello, Heritan. Hello, Anu. Good evening. Good evening, my dear lovely warriors. I hope I'm audible and to all of you. Very good. Awesome. Awesome. Show some josh, show some fire in the chat box. The lecture has just begun. Exactly. Very nice. Awesome. Okay, so let's begin. Let's begin. Let's begin. Let's begin. The Josh means enthusiasm and energy. That's what Josh means. And today we are going to complete motion in 2D, not the relative part, but mainly the projectile motion, inclined plane projection, and also projectile from a hill. And also, in general, motion in a plane. That is what we are going to do. We'll have a separate session just for pure relative motion, like your Rain Man problems and riverboat problems and shortest distance and all those things. That's what we are going to do. And this is your Captain Shreyas. And if you're new to the channel, quickly introduce yourself, me as well as others, and get set go. Keep your notebooks ready, keep your mind open, and keep yourself hydrated, full of energy, because this session is going to be intense with 3 level of problems. That's what Roar series is all about. Your one-stop solution for your JEE preparation. In detail classes, crisp classes with multiple problems, with DPPs, with class notes, and obviously the recordings are there. So show your love by smashing the like button and subscribe to the channel so that you do not miss any class which I'm going to conduct over here. Okay. And let me also tell you, as you're watching this video, in the description box, you have the Jungle Book. What is this Jungle Book? You will find a lot of animals over here. Which animals will you find? Let's see. Okay. So let me open the Jungle Book. Yes. Yep. You can see join the Jungle Book. What is this Jungle Book? See this. Yeah. You will see all the lecture links, all the PDF notes, all for free of cost is available here, including the DPPs. Whenever we complete a lecture, it will get updated. Okay. So physics, maths, chemistry bifurcated. Not just that. Now we are also going to put other lectures like BitSat and other COMEDK, EMSAT, SRM, VIT, board lectures. Everything will slowly start showing up right over here. It's a one-stop solution for all the lectures, notes, everything. Okay. So that's the reason why you should be a part of Jungle Book. It's absolutely free of cost. So my dear warriors, let's begin. Let's begin with the class of kinematics and 2D motion, and you will realize that kinematics is nothing but just Angry Birds in real life. If you have played Angry Birds, you know Angry Birds game where you throw that bird and it goes in an inclined path, it goes in a curvy path. That uses the knowledge of motion in a plane or kinematics in 2D. So that is what this is all about. Hi everyone. For JEE drop, I have already made a strategy video on the channel. Just check it out. Just check it out. It's already there. Everybody is ready. Hi Dharnishwaran. Hello Subita. Okay. So when I say motion in a plane, understand what do I exactly mean over here. See, we have studied one-dimensional motion where, say for example, there was a particle, it was going here, then going here, etc. Maybe, it was going along x direction. Now, maybe this particle also has its motion, in the y direction. Maybe it is going up, maybe it is coming down, maybe it's going up, down, whatever. It's having some motion in the y direction. So if you combine two one-dimensional motions together, what you get? What you get is probably the net motion of that particular particle. Maybe it has gone here and here like this till this point. So you will get a two-dimensional motion. That's all it is. So at the end of a day, a two-dimension or basically three-dimensional motion is nothing but the the combination combination of two or three, two or three, one dimensional motion. 2 or 3 one-dimensional motion. As simple as that. So whenever I have a particle which is going in 1D or 2D, it could be even 3D problem, by the way. Let's say this is a 3D problem. There is a particle which is going like this over here, or it could be going like this over here. Then at any instant, you can do one thing. You can just drop perpendiculars. You will get the x coordinate, you will also get the y coordinate, and you will also get the z coordinate. This is y, this is probably x, and this is probably z. So the particle will have all the 3 coordinates, and I will know every detail about it: x, y, z. So the x coordinate might change, the y might change, z might change. Each of these coordinates, when they change, they are changing in 1D. So when I combine these one-dimensional motions together, I get the 3-dimension or 2-dimensional motion at the end of the day. Everyone, till this point, is it clear? That's why we study 1D motion first and then we go to this. Okay? In fact, you're going to see everything is going to look so similar that you will find that it is more or less like a repetition. Starting off with position. Position means where. Position means where are you? And this where is always with respect to an observer. Where is always with respect to an observer. Observer, basically your point of view, POV, which you call. So where are you with respect to the observer? That is nothing but position, and it's a vector quantity. That vector has a symbol R usually. So if I use the symbol Ri bar, it means initial position. It means initial position vector. Initial position vector. If I put Rf bar, it means what is my current or what is my final position vector. What is my initial or final position vector is represented by Ri or Rf. So say for example, my dear warriors, you know, this was my frame of reference, the point of view as you call it. And let's say we had a Pandu who had wings and he is flying. Pandu drank Red Bull, he got wings and he is flying, and maybe he went here after some time. This Pandu went here. So I would then say from this origin to this point, this is nothing but the initial position vector. This is nothing but your initial position vector, Ri bar. Finally, Pandu reached here. So this then would be the final position vector. Initial position, final position. In general, it could be R. So Pandu has traveled, has flown like this. He got wings. Okay, so that is what position vector is all about. So if you know the coordinates of Pandu, if by chance you know the coordinates of Pandu, let's say this is our P, Pandu, or particle, whatever you want to call it, and the coordinates are x, comma, y, comma, z, then the position vector, r bar, this position vector r bar is just given by x I cap, y j cap, and z k cap. As simple as that. X coordinate I cap, y coordinate j cap, z coordinate k cap. That's it. That is your position vector. Okay, so if you know the coordinates, immediately you can tell me what position is going to be. Very, very straightforward. Hi, Satish. Okay. Subita, I'm not really sure, but it will go until 7, 8 o'clock. Yeah, that is our usual time, depending on how things go. So I don't fix the time because we don't know. We just go with the flow as long as it takes to make you understand and clear things out. Okay, we take it at a very normal pace. We don't go very fast. We don't go very slow. Now comes the next is displacement. Observe this. See, Pandu was initially here, then Pandu went here. This was initial, this was final. So, from initial location over here, Pandu reached here. So, this would be the displacement of the Pandu. I will call it as S. Remember, this displacement symbol was S. So this is the displacement. This was nothing but the initial location where you were there. This is nothing but where you are finally. You might have gone to this path via some lengthy, uh, you might have gone to this point via some lengthy path. That's okay. But displacement is always the straight line which joins the initial to the final location. If you notice, it forms like a beautiful triangle. And if you remember vectors, this is vector A, this is vector B. By triangle law, this is the resultant vector. So easily one can see R final is R initial plus your displacement This vector plus this vector is the resultant vector. So therefore displacement will be, take Ri on the other side, it will be Rf minus Ri. It is the difference of the positions. It is the change. Difference is change. So hence, often you will see the symbol delta R over here. You will often see the symbol delta R over here. So displacement is nothing but the change. Delta is nothing but change in the position. The change in the position. The change in the position. I can make a simple question out of this. It's the same thing which has been written over here. Okay, displacement is nothing but delta, which is the change in the position. Say for example, my dear students, I tell you, listen, Pandu was there initially at the coordinates 2, 0, -3. Pandu finally reached some place which is having the coordinates 3, 1, let's say 2. Question is, what is the displacement of Pandu? What is the displacement of Pandu? That is the question. By definition, what is displacement? Change of position, right? What is displacement? Displacement is nothing but final minus initial position. If you remember some time back, I had told you position is coordinates I cap, coordinates j cap, coordinate k cap. So you put all the coordinates with the respective unit vectors along the xyz direction. So for final, use these coordinates. Actually, final position is 3 I cap plus 1 j cap plus 2 k cap. If you look at the initial position, it is having the coordinates 2 I cap, 0 k cap, and -3 k cap. Now you just have to do normal subtraction or addition, that's it. So 3 minus 2 is basically 1, so I cap. J, nothing to subtract, so plus j. Plus 2 plus 3 will become plus 5, so plus 5 k cap. So the displacement is I cap plus j cap plus 5 k cap meters. Very nice. Very good, Subito. Very good, Herboroin. Awesome, Dharinishwara. That is the displacement. Okay. So if you know the coordinates before and afterwards, you can easily look at the displacement. Now comes the next thing, that is the velocity. Next thing which comes is the velocity and acceleration vectors. So let me just create some more slides. If I want to find, okay, listen, this is the displacement. Let's say this is the displacement which we just figured out is nothing but delta r, and this occurred in time of delta t, in a time of delta t. Then I can write the average velocity. What is it? Average velocity. The average velocity, the average velocity is how much displacement has been done upon the time taken for the displacement. Upon the time which has been taken for the displacement. So average velocity will be displacement. What is the displacement? It is delta r upon how much time you took? Delta t. That is it. That is the value of average velocity. That is the value of average velocity. So if I go back over here, let's say Pandu went from this location to this location in a matter of, let's say, 0.5 seconds. Example, Pandu went to this location in a matter of 0.5 seconds. Then, if I ask you what is the velocity of Pandu, if I ask you what is the average velocity of Pandu, what you will do? You will take the displacement and divide it with time. So in this case, I already figured out the displacement, which was I cap plus j cap plus 5k cap divided by 0.5. So 1 by 0.5 is basically 2. So 2 I cap. 1 by 0.5 is again 2. So 2 j cap. And 5 by 0.5, that's nothing but 10. So 10 k cap meters per second. That is the answer. So that is the average velocity of Pandu. That is the average velocity of Pandu. Just divide the displacement with time. Nothing more, nothing less. This was average. So then if I ask you what is going to be the instantaneous value? Well, just look at this, my dear students. Say for example, Pandu was going along this particular path. When I say instantaneous, I need to take a very small time. So we need a very small displacement also. So imagine Pandu has undergone a very small displacement over here like this, and that is ds, or I would rather put it as dr. That is a very small displacement in time dt, in a very small time dt. dt means nothing but delta t has become very, very small, tending to zero, approaching zero. So then the velocity at that location, then the velocity at that location, number thing, observe a very, very important thing, guys, over here. Observe a very, very important thing. That velocity you will see is along the tangent. This velocity is number one along the tangent to the curve. Very, very important. Not in any other direction. If the particle is going like this, my velocity can't be here. My velocity can't be here. It has to be tangential to the actual path taken by the particle. So, number one, velocity is tangential to the to the what? The path taken, to the path which has been taken. So if I take that infinitely small displacement and divide it with time, what I will get is the instantaneous velocity. So this is your instantaneous velocity, dr by dt. Instantaneous velocity, which is nothing but dr by dt. Example to find out velocity would go like this. Imagine I tell you, hey, there is a particle which is going in some random curved path, and the x coordinate is given by 3t raised to 4, and the y coordinate is given by, let's say, t square. Can you find the velocity and the speed of the particle? Can you find the velocity and the speed of the particle at any moment? Well, I think we can do that very easily. Velocity is the rate of change of position. Fine. So what I will do, I'll just write down velocity is dr by dt. But what is r? Okay. R is x I cap plus yj cap. Oh, what is x? 3t raised to 4. 3t raised to 4 I cap. What is y? Y is basically t square j cap. So once I know what is the position vector, I can find velocity vector, which is the derivative of this. Which is the derivative of this. So derivative of 3t raised to 4 will be 3 into 4t cube I cap plus t square's derivative is 2t, and then there is j cap. Therefore, the velocity will be, how much is this? 12 t cube I cap plus 2t j cap. As simple as that. That is the answer. Everybody with me? Understood? Clear? How do you find the velocity? You find the position. How do you find the position? Because the coordinates were given to you. That's why you were able to substitute the coordinates to get the position. Differentiate this, derivate this, you will get the velocity. But there is one more question in this problem, and that is the speed. No issues. We can find the speed. Speed is nothing but the magnitude of velocity. is the magnitude of velocity. So hence, you just take the magnitude of this. So it will be 12t cube whole square plus 2t whole square under the root. So this is the speed, as simple as that. So if you substitute the value of time at any instant, you will get the speed. Is that okay? So speed is nothing but the magnitude of the velocity. So this is how you use these equations. Let's go to the next part, and that is acceleration. Ready for the acceleration part, my dear warriors? Ready for the acceleration part, my dear warriors? Okay, got it, everyone? Awesome, awesome. Imagine there is a particle which is going like this, which has some initial velocity or which has some velocity at some moment, and maybe it is going on a path which is curved in 2D or whatever. So after some time the velocity changes. This is the new velocity and this is v plus some delta v. Delta v is the change in time dt. In time, let's say delta t. In time, let's say delta t. Over this period, the velocity has changed and hence there is acceleration. So when velocity changes, when velocity changes. Now, when I say velocity changes, there could be two things. There could be two things what I'm saying. Either the magnitude has changed or the direction has changed or both have changed. Either that, Pandu was going like this, now he turned. That's one way you can change the direction and change the velocity. Another option is I increase my speed or I decrease my speed. That also is going to cause change of velocity. So whenever there is change of velocity, then you are going to say there is acceleration. There is acceleration. In fact, the average acceleration formula is as simple as change of velocity divided by the time taken. That's it. It is how much did my velocity change upon what is the time taken. That's all is there to find average acceleration. Change of velocity by the time interval. Say for example, you know, we have we have let's say a particle going like this um, with a velocity of 2 I cap plus 3 j cap, and let's say it turns like this and the velocity becomes, this was meters per second, the velocity let's say becomes I cap plus 4 j cap meters per second in a matter of 2 seconds. Can we find the acceleration of the body? The answer is yes. I know the initial, I know the final, I know the time. So I can easily find the acceleration like this. By definition, it is how much the velocity changed upon the time taken. Please remember this quantity over here is again final minus initial. Final minus initial. So let's do that. So acceleration is final velocity minus initial velocity upon the time taken. What is the final? It is this, I cap and 4j cap. What is the initial? 2I cap and 3j cap. What is the time? Time taken is 2 seconds. Okay, let's put 2 over here. I minus 2I will make it minus I. 4j minus 3j is just going to make it j. So by 2. So that many meters per second square is the acceleration. So the acceleration is minus I cap plus j cap, whole thing divided by 2. How many of you got it? Oops. I think by mistake the DNA watermark is there. Thank you, Adiksha. Okay. Understood? If somebody asked you, what is the magnitude of the acceleration? If somebody asked you, what is the magnitude of the acceleration? What will you do? You will just take the components and square it. So first component is minus 1 by 2. Next component is just 1 by 2. Square it, add it, put it under. What will you get? 1 by 2 square is basically 1 by 4. 1 by 4 plus 1 by 4 is basically 1 by 2. Hence the answer is 1 by root 2 meters per second square magnitude wise. magnitude wise. Exactly. That's the answer. Okay. Guru Baswa, yes, whatever doubt you have, you can ask. Is this point clear? How do we find average acceleration if the velocities are given? Last thing over here would be the instantaneous acceleration, where within negligible time, the velocity has changed in moving from this point to this point in time dt. In a time of dt, the particle has hardly or barely turned, and the velocity is now v plus dv. The velocity has changed by a small amount in a very small time. So then I will have instantaneous acceleration. Instantaneous acceleration. Symbolically, I will just put A. It is nothing but your rate of change of velocity. Rate of your change of velocity. This is nothing but rate of change of velocity. It is dv by dt. That's it. It's nothing but dv by dt. Instead of delta v by delta t, instead of big interval of time and big change in velocity, it is the small time and small velocity which has to be considered. As simple as that. Say for example, I tell you, x is nothing but t square and y is nothing but t cube. Can you find the acceleration of the particle? Well, let's find out. To find acceleration, I need to know velocity. To find velocity, I need to know position. Only then I can do it. So let's start with the basics. Position will be x I cap plus y j cap. What is x over here? It's t square. What is y over here? It's t cube. Okay. So that is position, but that's not what I want. I want, velocity first to find acceleration. So velocity is dr by dt. Okay. So I have to take the derivative of this. So derivative of t square is basically 2t, and derivative of t cube is 3t square, T square's derivative is 2t, t cube's derivative is 3t square. As simple as that. We just found out the derivative. But that's not all. We have to go to acceleration now. So the next step will be to find acceleration, which is rate of change of velocity. So you have to find the derivative of 2t. What is the derivative of 2t? It is just 2. So it will be 2 I cap. 3t square's derivative. 2 comes outside. 2 3s are 6. 6t j cap meters per second square. So the acceleration is 2 I cap plus 6t j cap meters per second square. Since it's a function of time, since acceleration is some function of time, therefore acceleration is not a constant. Acceleration is not uniform, it is not constant. If this time was not there, then every instant the acceleration will come out to be the same value. So then the acceleration would be constant. But in this case, it is a function of time. So it is a non-uniform motion. This is how you solve any complex problem where acceleration is not constant, velocity is not constant, position is not constant, everything is non-uniform. Use derivatives. Very good, Adiksha. Very good, Dharneshwaran. 3t square j cap, Dharneshwaran. Yes, that was velocity, I guess. Yep, correct. Awesome. Perfecto. So we have learned till now position, velocity, acceleration, and they are all related by derivatives. Needless to say, if you want to go on the top, if you want to go from here to here or from here to here, you have to integrate. So integral of acceleration with respect to time will give you velocity, Integration of velocity with respect to time will give you position. Obviously, you have to put limits, or else if you just put without the limits, there will be constant of integration. If you avoid constant, you have to put limits. As simple as that. So this way derivatives, upper way integration, this is what we have seen. Now, before we proceed to final set of problems, I want you to understand this very clearly. Very, very important. In one-dimensional motion, velocity and acceleration are always along the straight line, either parallel or anti-parallel. But for motion in 2D or 3D, velocity and acceleration can be in any direction. Velocity and acceleration can have any relative direction, understand what it means. Say for example, this is the first case, velocity. Next case, velocity. Another case, velocity. One more case we'll take, and one last case over here. And now we'll take different directions of acceleration. Now we'll take different directions of acceleration. Let's say first time the acceleration is over here, parallel. Next time makes an acute angle. Next time makes an angle of 90 degrees. Next time makes an obtuse angle. Next time makes an obtuse angle with the velocity. Last time it makes an angle of 180 degrees, or basically it is opposite. The first scenario and the last scenario are basically motion in 1D. That first line which is there, motion in 1D, acceleration is either parallel or opposite to the velocity. But in 2 dimension, acceleration velocity can be in any direction. There is no need. If a particle is going like this, acceleration is also like this. It can be in some weird looking direction. That is what that second line says. But what is very interesting in these diagrams is that if you consider these two cases, if you consider these two cases specifically, you will see that in both these cases, there is a component of acceleration along the velocity. There is a component of acceleration, has two components in the direction of velocity. Here, there is a component of acceleration against the velocity, against the velocity. So in these two, you will see there is a component of acceleration against the velocity. So what you will see is in this and this case, the speed reduces. In these two cases, the speed basically reduces. Exactly. Whereas in this particular case, because it is in the same direction, what you will see is the speed increases. The speed is increasing. The speed is increasing. Whereas in this scenario, you will see there is no change in the speed at that instant. There is no change in the speed at that instant shown. It is neither increasing nor decreasing. Very, very important. I'll show this to you by a simple example. Imagine you take a ball and throw it at an angle. The ball goes like this. The ball goes like this. If you notice here, the velocity is in this direction. At this point, the velocity is in this direction. At this point, the velocity is in this direction. But throughout the journey, one thing is common, and that is acceleration, which is always going to be downwards. G vector, your acceleration due to gravity, is always going to be downwards. Is that right? So now think and tell me, my dear students, when the ball is going up, won't the speed reduce? Won't the speed decrease? The speed is decreasing as the ball goes up. And why is that so? Because the angle is obtuse, just like it has been predicted here. If the angle is obtuse or opposite, the speed reduces. Perfect. When you are coming down, the speed will definitely increase. The speed increases. And you can see one very interesting thing, the angle between velocity and acceleration is acute. Just like over here, the speed is increasing. And exactly at the topmost point, it stops changing. Here, at this point, it stops changing. It stops changing at this particular point. Till this point, it decreased, and then it started increasing and then increasing. So in fact, can I say at this particular point, the speed was minimum? The speed was minimum at this particular point. Agree or disagree? Because it decreased, increase, decrease, and then started increasing. So there comes a point of minimum. So the speed is minimum at the topmost point. Yes, yes, Basim, Abdullah, I will be doing projectile on an incline also in this session. Till this point, is everything absolutely clear? Everybody, how acceleration and velocity can be in any possible direction. In any possible direction. Correct. So let's move to some questions coming up on your screen. And here is the first level 1 question. A body is moving with a velocity of 30 towards the east. After 10 seconds, the velocity becomes 40 towards the north. From 30 towards east, after 10 seconds, its velocity becomes 40 seconds towards the north. The question is, what is the average acceleration of the body? Let's draw the diagram to understand it. 30 meters per second towards the east is like this. So 30 I cap meters per second. This is initial. So it turns towards the north. That means it goes like this. And the velocity finally is 40 j cap meters per second. How much time it took? 10 seconds. It took basically 10 seconds. Question is what? Find the average acceleration. By definition, what is average acceleration? Final minus initial velocity by the time. What is final velocity? Well, it's just 40 j cap. There is no component other than that. What is initial velocity? That's just 30 I cap. The whole thing divided by the time, which is basically 10 seconds. 0, 0, 0 goes. So it will become 4 j cap minus 3 I cap. But we usually put I cap first. So minus 3 I cap plus 4 j cap meters per second square. That is the acceleration. But if somebody asks you the magnitude, then you will be like, okay, minus 3 square plus 4 square, which is root of 25, which is 5 meters per second square. If somebody asks you to, come on, show the acceleration, where is it? Minus 3 I cap is left side, plus 4 j cap is upwards. So the acceleration is actually in the north and somewhere in the west direction. So it is somewhere here. It is basically somewhere over here. This is where the acceleration is on an average. Is that okay, my dear warriors? Understood this particular question? Magnitude wise 5, direction wise it is somewhere in the northwest direction. Hello, Charan. Awesome, awesome. Let's move to the next question on your screen. X and Y coordinates of a particle are 5t minus 2t square and y is equal to 10t respectively. The acceleration of the particle at t is equal to 2 seconds is how much? Like you can see, from x and y coordinates, we can immediately figure out the position, which is x I cap means 5t minus 2t square I cap and plus 10t, then you have j cap. So the first thing that we will do is find out the velocity. So velocity is the derivative of the position. So take the derivative of this. 5 into derivative of time is 1 minus 2 into derivative of t square is 2t I cap plus 10 into derivative of time is just 1, basically j cap. So the velocity will be 5 minus 2t I cap plus 10 j cap. But that's not all. We have to find the acceleration also. No issues. Acceleration is the derivative of the velocity. So when you take the derivative of this guy, 5 is a constant, derivative is 0. 2t's derivative is just 2. So plus 10 is a constant, so derivative is 0. So therefore, the acceleration is minus 2 I cap meters per second square. So you might wonder, what about 2 seconds, sir? No use. In fact, there is no time in the equation. That means the acceleration is a constant. Doesn't matter 2 seconds, 3 seconds, 100 seconds. It's a constant value. It's a constant value. Oh, sorry. I think 2 into 2. I missed one of the 2's over here. I'm so sorry, guys. I missed that 2. So sorry. This was supposed to be minus 4. I'm so sorry. Just changing it right away. 0 minus 4. And this is also minus 4. And this was basically. Now it was fine. Yeah. So minus 4 I cap meters per second square. Just check this out. Yes. Clear? Shall we go ahead? Shall we go ahead to the next question? Very straightforward questions coming up on your screen. Okay, level 2 question. This was asked in previous years, that's why it's level 2. The position coordinates of a particle moving in 3D. Might be wondering, sir, 3D problem you did not teach. Doesn't matter. As long as you know vectors, as long as you know vector resolution, as long as you know the basics of 2D, you can solve 3D problem also. So this was a three-dimensional question which was asked in previous years. X is a cos, y is a sine, z is a omega t. Find the speed of the particle. Find the speed of the particle. That was the question. All right, come on. Let's see if you guys can figure this out. Let's see if you guys can figure this out. Question is, what is the speed of the particle, my dear warriors? So first of all, what will you do? What will you do? Come on. I think there was no time over here. I think this time by mistake it has been printed. It shouldn't be there. I think this was just a omega. Yeah. Now I think it should be fine. Ha. You will first find the position and then differentiate it and then find the speed. So position was nothing but x is nothing but a cos omega t I cap. Y coordinate is a sine omega t j cap. And lastly, z is a omega and that is k cap. So let's find velocity, which is nothing but the derivative of this. So the derivative of this, a cos's derivative is negative sign. But when I take the derivative, remember this omega will also come outside. So into omega, that will be I cap. Then next term, sine is there. So derivative of sine is basically cos. So a cos omega t j cap. But do not forget this omega should also come outside by chain rule. And oh, sorry, this sine will be there or else will not get. Sorry. Or else will not get. It was correct. And over here, this was a omega t and this was k cap. So derivative of a omega t will just be a omega and that's it, times derivative is 1. Now once I get the velocity, I want to find the speed. So that means the magnitude. So all you need to do is take this, square it, add it. So you will have a omega sine omega t whole square plus a omega cos omega t whole square plus a omega whole square. Notice one interesting thing, a omega is common. Outside the root, it will just become a omega. Inside, you will just have sine square omega t plus cos square omega t, and there is 1 left over here. Sine square plus cos square is 1. Sine square plus cos square is 1. So therefore, it will be just nothing but 1 plus 1, which is root 2. So it will become a omega root 2. So a omega root 2 is option A. Let's check it out. Yes, it is option A. It is option A. Okay. Is Roar series equivalent to Pathfinder or other series? Supriya, it is a much more improved and refined version and a much more, I would say, a detailed version plus some advanced problems. So I feel if you have watched Pathfinder, you will see a lot of difference. Yes, because that was, 2-3 years back, right? Or 4 years back. So this is obviously a much better version. Needless to say, that was also good for its times, but always there is a room for improvement, right? So that's why I would suggest you to watch the Roar series. Cool. So now that we have understood how to solve any non-uniform motion problem, three-dimensional motion problem using derivatives, there are much simpler problems also that you get, and that is with constant acceleration. Whenever your acceleration is constant, this is very, very important, my dear students. Observe this very carefully. Your particle might be going in a curved path, but acceleration should be constant, meaning direction should be also same, magnitude should also be same. Direction should also be same, magnitude should also be the same, no matter where it is. Okay. Vishal, it will come up. Gauss law notes are not yet attached, is it? I'll just check. Maybe it should be attached by now, but if it is not, just I'll let the team know at the back end. Then all kinematic equations are valid. All kinematic equations are valid. All the kinematic equations are valid in 2 dimension or even 3 dimension. So you'll put final velocity is nothing but initial velocity plus acceleration into time. Displacement is nothing but your initial velocity into time plus half acceleration into time square. Final velocity square magnitude wise is initial velocity square plus 2 into acceleration dot producted with displacement. Displacement in the nth second vector is the initial velocity, okay, plus acceleration by 2 into 2n minus 1. All these equations are valid. Remember, the third equation has a dot product over there. That is the only catch. Other than that, everything else is straightforward. Alpha, if you're watching both, even better, you will see the problems are way different. I mean, I'm not repeating any problems from the previous series. So that's one advantage, because I know some of you will be watching both and you want to make the best use of it. I'll tell you one interesting thing. In 2-dimension and 3-dimension, you can solve the problems in vector form, but somebody decides, no sir, I want to solve x separately, y separately. No issue. You can solve it for x and y separately, and you can still use the kinematic equations with the separate components. So both are fine. There is nothing wrong in it. Both are fine. Yeah, there is nothing wrong in it. Now, how do I exactly use it? So for that, I have a question for all of you. Then we will be able to discuss it. Okay, so let's solve this particular question. Let's solve this particular question. Velocity at time 0 is this, and acceleration is constant. You can see. Find the velocity and displacement at 2 seconds. Let's try to do that. First, let's go with velocity. After 2 seconds, we want to find it. So I think I will use final velocity is initial velocity plus acceleration into time. What is the initial velocity? It is given right over here. It is a 2i cap plus 3j cap. Acceleration is given to be 4i cap plus 2j cap. 2j cap. How much is the time? It is basically 2. So 2 4s are 8. 8 plus 2 is 10. So 10 I cap. 2 2s are 4. 4 plus 3 is 7. So 7 j cap meters per second. That is your final velocity at 2 seconds. If you want, you can find x and y also separately. If you want, you can solve it for x and y separately. For example, one might say, I will just solve for x first. So if you look at x components, it is this. So the x velocity will be ux plus ax into t. Ux is 2, acceleration is 4 into time. So it will be basically 10 meters per second. Then solve it for y separately, which is uy plus ay into t. Uy is basically 3, acceleration is basically 2, time is basically 2. So it will be again 7 meters per second. I got x and y components. So the total velocity will be 10 I cap plus 7 j cap meters per second. Either ways, you will get the same answer. But which is more preferred? This is lengthy because you are solving it separately. This sounds better. This sounds better because obviously it's like solving both of them together. And the best part is I cap will only interfere with I, J will only add or subtract with J. So it's like solving two problems together without I and J bothering each other. This does not affect this does not affect it. You are solving two problems together over here. That's what it is. Looking at the displacement part, let's solve the displacement. We can use the second kinematic equation. So S bar is nothing but initial velocity into time plus half into acceleration into time square. Initial velocity is 2i cap, 3j cap, time is 2 plus half, acceleration 4i cap plus 2j cap, and t square, t is 2. Okay. So what will this be? 2 2s are 4, 4i cap, 3 2s are 6, so 6j cap, plus 2 square by 2 is 2, 2 4s are 8, 8i cap, 2 2s are 4, so 4j cap. Okay, so 4 plus 8 is basically 12, so 12i cap. 6 plus 4 is basically 10, so 10j cap meters. So the displacement is this much, 12i plus 10j. 12i plus 10j. How many of you got it? Understanding? So whenever you have to use kinematic equations, check whether acceleration is constant and you can solve it in the vector form only. It becomes very easy then. It becomes very easy then. You don't have to break your head so much. Okay. Let's go to another question. This is asked in Tattva. So, guys, this is our Tattva module. This is our Tattva module. I'm taking the questions from this particular Tattva module only. Okay, for some questions like, because this has good level of questions. This has some solved examples are there. Then there is level 1 question, and the level 1 questions are also arranged, from topic to topic. Like question number 87 to question number 100 is from this topic. Question number 100 to 102 is from 105 is from this topic, like that. And then exercise 2 is previous year question. Exercise 3 is basically your JEE advanced questions, and exercise 4 is previous year JEE advanced question. So the levels are there and the solutions are also there if you scan the QR code. So when you scan the QR code, solutions will come. So you can solve this particular book for more questions. Okay, there are some really amazing questions. So I'm taking a lot of questions from here too. All right. Well, what is this question? Find the time when it crosses the x-axis. Initial coordinates are 4 and 10. Okay, let's try to think about it. Initial coordinates are 4 and 10. This is your x, this is your y, 0, 4 and 10. So initially it is somewhere over here. Find a time when it crosses the x-axis. Maybe the particle goes like this and it has to cross the x-axis. Okay. This was 10, this was 4. This is initial. When it crosses the x-axis, what is so special about it? What is so special about it at this particular point, my dear students? Come on, think and tell me what is so special about this point. Yes, the y coordinate is 0. The y coordinate is 0. Everybody gets this? Everybody gets this? Yeah, we don't have to integrate right now. I mean, its initial velocity and acceleration are given. Find the time when, yeah, it crosses. So the question is basically to find when the time, when means time. Okay, it crosses x-axis. So, my dear students, y coordinate is 0. So the whole problem, I think, now concentrates and revolves around the y direction. Just ignore the x direction for a moment. Initial y coordinate is 10, final y coordinate is 0. So, if you look at it, the displacement along the y, which is final y coordinate minus the initial y coordinate. Final is 0, initial is basically 10. I think the displacement is negative 10 meters. That is the displacement. And wait a minute, displacement formula I already know. What is the displacement formula? It is ut plus half at square, but everything in y direction. Everything in the y direction. So let's use that. Minus 10 from here. Initial velocity in the y direction is 8. Time, in fact, I do not know. Time, I do not know. Plus half into acceleration. Acceleration, do you see, is negative 4. Everything in the y direction only. Into time. Time is something which I do not know. Everybody with me on this? Understanding it till this point? Understanding it till this point, my dear warriors? Very good. So what is going to happen? Let's see. 4 and 2 cancels. It will just become minus 2t square. This will just become 8t. This will just become minus t. So take 2t square here, 8t here. So 2t square minus 8t minus 10 is 0. Divide by 2, it will become t square minus 4t minus 5 is 0. I think it's a proper nice quadratic equation. T minus 5t plus 1. So t minus 5 into t plus 1 is equal to 0. So t is equal to 5 or minus 1. But we know time can't be negative. Time can't be negative. So the only possibility is positive value. So this happens at 5 seconds. At 5 seconds. That is the correct answer. So at 5 seconds, it crosses over here. Is that absolutely clear, my dear warriors? Okay. Nanu, this is an English channel. There are a lot of Hindi channels out there. So we started the revolution in English. So I will be talking in very simple, slow English only. So, this will be a lecture in pure English. Sorry. Okay. We have a lot of Hindi channels too. Now, yeah, minus 10 part. See, Here, you started from this point. It was given 4 comma 10, 4 comma 10. I eventually reached here. Why? Because it's given the time when you cross the x-axis. So final y coordinate is 0. So final y minus initial y coordinate is the displacement in the y direction. Displacement, what is the formula? Second equation, ut plus half at t square. Ut plus half at t square. So instead of u, you will put 8. Instead of acceleration, you will put -4. Why? Because this is j cap. J cap is y direction. Ignore the x because the whole problem has now been narrowed down into y direction. Just had to, yeah, uh, look at only y direction. Sir, but it had initial velocity and acceleration. How can we find displacement with only the coordinates? Alpha, I'll just ask you a simple thing. Imagine there is a car, you know the initial velocity, and you know how much it moves. You also know how much it accelerates. Can't you find how much time for which it accelerates? I know initially it was moving with this much speed, now it is accelerating with this much acceleration. I know it moves this much. So can't I find the time for which it moves this much? Displacement is known. Yes. Initial velocity is known. Yes. Acceleration is known. Yes. Finding time. One unknown in that entire equation, which is now quadratic. Makes sense? Usha Tattva is a very good material for getting 98, 99 percentile easily. Yeah. Time can't be negative means you have gone in the past. This is in the past. Okay. Lucky, I know you are only DJ Tilu. Looking at your emoji, looking at your capital typing, I know it is DJ Tilu. Already in the chat box. DJ in the chat box. If there was another question in this, and that question said, where does it cross? Where does it cross? We just now got the answer is 5 seconds. This is crossing at 5 seconds. If there was one more question over here, find the time when it crosses and where does it cross. Where means on the x-axis, where does it cross it? So I am interested in that x coordinate. I am interested in that x coordinate. What will you do in such a case? What will you do in such a case? Think about it. In order to find that, I think I have to write some x-axis equation. This is regarding displacement. So I will use S is ut plus half at square, but this time in the horizontal direction. So how about using Sx is equal to ux plus half ax t square. Everything has x in it because I'm only interested in x. What is displacement formula? Displacement formula is uxt plus half x t square. That's one. Correct? Second kinematic equation. Okay. Do I know the initial velocity in the x direction? Yes. It is nothing but 4. Do I know the time? Yes. 5. Half into acceleration. Do I know the acceleration? Yes. It is 2. Do I know the time? Yes. I just figured it out. So what is remaining? Displacement. Okay. So how much will this be? This will be 20. 2 cancels. This will become 25. This will become 45 meters. So the displacement is 45 meters. Be very careful. Be very careful. The answer is not 45. Displacement is 45 means from here to here is 45 meters. It already had some x displacement. It already had some x coordinate, which is 4. Do not forget that. Actually, displacement, if you remember, by definition, is final minus initial. What is final? That is what I have to find. What is initial? That is 4. So x minus 4 is basically 45. Is basically 45. So hence your final coordinate, will be 45 plus 4. Hence it will be 49 meters. So at 49 meters from the origin, it will cut the x-axis. At 49 meters from the origin, it will cut the x-axis. Okay, I hope this is clear. Why we took 8 j cap? and minus 8 j cap and minus 4 j cap, because this was for y. Look at this. When we were writing this equation, everything was in y direction. Everything was in y direction. So y means j cap, j cap. That's why initial velocity we took 8 and acceleration we took minus 4. Acceleration we took minus 4 because we are solving only for y. Why were we solving for y? Because I knew final y coordinate and initial y coordinate, so the displacement I knew in the y direction. That's why we took everything in y. But for the second part, we solved it completely for x. That's why I took 4 I cap and 2 I cap. 4 I cap and 2 I cap with the time which was already found. Is that okay? Everyone? Awesome. Shall we go ahead now? Shall we go ahead, my dear students? Ready for the next question? Now is it clear? Okay, let's go to the next question. So guys, these are Tattva questions. That's why I say you have to solve Tattva. Students who solve Tattva modules, they become really experts in all the subjects. This is the previous year question. A particle is starting from the origin with some initial velocity, moves in the xy plane, constant acceleration, x coordinate when the y coordinate is 32. Interesting. Find x when y is 32. So first, will you solve for x or will you solve for y? Think about it logically. You don't even know when is the y coordinate 32. If I knew the time, I would have directly started for x, but there was no time mentioned in the problem. So in order to find the time, I will start with the y-axis, then I will go to the x-axis. Yes, alpha, we must first find the time. So let us start solving it for the y coordinate. And it is starting from the origin. So displacement in the y direction is uyt plus half AYT square. Everything, second kinematic equation in the y-axis. Displacement in the y direction. Well, initially it was at the origin. It went through 32. So the displacement itself is 32. Displacement itself is 32 in the y direction. Initial velocity in the y direction. Oh, look at this. 3 I cap. There is no j cap. There is no velocity. Do you see that? There is 0 j cap. There is 0 j cap. There is 0 j cap. Guys, this velocity is just 0 plus half. Acceleration in the y direction is 4 j cap. So plus 4 time I do not. Therefore 4 by 2 is 2. So 32 divided by 2 is basically t square. 32 by 2 is 16. So time is basically 4 seconds. So at 4 seconds, the y coordinate is 32. Amazing. Now what do we do? Now look at the main question. The main question says find the x coordinate of the particle. So let's solve it. Sx is uxt plus half ax t square. Ux, initial velocity in the x direction, 3 I cap. So I'll just put 3. Time from here, 4 plus acceleration, 6. Time from here, which is basically 4 square. So this will be nothing but 12 plus 6 by 2 is 3. 4 square is 16. 16 into 3, that's 48. So that's just going to make it 60 meters. So displacement is how much? 60 meters, my dear audience. So this should be the answer. Yes, it is 60 meters. Perfect. Awesome. Awesome. Very good. Very good. Yes, Alpha, it is not 24, it is 60. Yes, Subita. Yes, Dharneshwaran. Awesome. Understood how to solve these questions. Got confidence in level 2 also now. Yep. Awesome, my dear warriors. Okay. So you have solved quite a lot of questions on this. So now let's go on to the main part of the chapter, which is basically the projectile motion. If you understand how x and y axis work kinematics wise, trust me, projectile motion is just a application of it. Some formulas are there. Yeah, that's fine. But apart from that, it is just kinematic equation. You throw anything in air upwards, it will do 1D motion. You throw it at an angle, it goes in a curved path. That is your projectile motion in 2 dimensions. That is what we are learning. You kick a football, it goes in a curved path. Where is it going to land? After how much time will it fall? When you watch cricket in IPL or in the World Cup, you might have seen they do all sorts of analysis. The ball is going to go like this and it is going to hit the stumps. You know, the mathematics behind it is what you are learning today. What is the equation of the path? How much time does it take? With what speed is it going? So all these calculations are done using these equations what you are learning today. Okay, whether the football is going to reach there or not, even missiles, rockets, all of them, you will see many of these applications are based on projectile motion. You throw something, you fire something, you just leave it, you throw a packet of food from the plane, where is it going to land? All these are examples of projectile motion. Avanishri, you have joined in at the second part of the lecture, but yeah, you can continue watching it. Hopefully, you will be able to understand. Not an issue. Yes. Any camera inside the ball? Um, I think these balls do have sensors. Even the wickets have cameras these days. Even those balls have sensors. Even there are very high speed cameras at fixed locations. They track. There are motion sensors, everything in a cricket field. It's a science and technology in itself when you just observe a cricket match. All those statistics, where the ball has hit the batsman, from where the bowler has left the ball, where has it pitched, and what was the speed, what was the angle. All these things happens because of cameras, sensors, motion detectors, everything inside the ball, near the pitch, from the top, from the side, sound. So many things are there just in one small cricket match. Yep. Okay. So when we are learning this projectile motion, when we are learning this projectile motion, I want you to understand a couple of things. And for that, mm, where did it go? Just 1 second. This is the best tool for animating it. So I was just checking this out. Let's go over here. Okay. And let's go over here directly. It's better to explain why this simulation rather than just drawing it on the board. Look at this. A beautiful, beautiful animation. All the parameters can be changed like the mass, the diameter of the ball which is being thrown, air resistance and all that. But remember, air resistance is something which we neglect. So just to show you how things work, let me just fire this. You can see this ball goes and oops, just missed that guy. So this was with air resistance. If I remove the air resistance part, I think it will go a little bit far away. And it has gone even higher, even for a longer time. So air resistance does make a difference. And we often neglect that air resistance, which is okay. We take it for granted. No issues. All right. Now coming to the point, if I change the mass, what do you think will happen? I change the mass. Obviously, nothing should happen. It will continue with the same thing. I change the diameter of the particle, nothing happens. It will still continue the same path. No matter which diameter, which mass I choose, acceleration due to gravity is independent of the mass or the size. So you will see that it will go along the same path. It's just like the Angry Birds. Yes, correct. So now here is what I want to understand. How is the acceleration going to be? Is the acceleration going to change the direction as it goes up and down? The answer is no. It always accelerates downwards. Observe this. Where is the acceleration vector? The yellow one. The acceleration vector is the yellow one. Let's try this out. Let's fire it. Do you see? The acceleration yellow vector is always down. If you want, let's go in slow motion so that you can see it. See how the acceleration vector, the yellow one, is always, Earth is always pulling it down. Acceleration due to gravity is always pulling it down. Notice how the speed slowly reduces, does not become zero, becomes minimum, and then again starts to increase, just like I discussed some time back. It again increases after some time back. Now let's look at the velocity. How does the velocity look like? As expected, it is very large initially. It becomes small, it becomes horizontal, and then it becomes large again. See the length of it. See the length of it, my dear warriors. If you want, I will change the angle, okay, so that you can probably see it. See how the velocity reduces, 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 horizontal, and again increases and increases before it hits the ground. Isn't it amazing, my dear warriors? So it has hit somewhere over here, close to 28 meters. Amazing. Now, let us look at the components. This was the total vector. Whatever I showed you was the total velocity vector. If I split it into components, what do you expect? Game name. The game name is called PHET. P-H-E-T. That sound when you get one slap on your face, phat. So that is the name, P-H-E-T. Okay, all right, awesome. So my dear students, if I take the components, what is that one interesting thing that you're going to see? See, my dear students, acceleration is down. There is no acceleration in the x. If there is no acceleration in the x, what do you think should happen? What do you think should happen if there is no acceleration in the x direction? The x direction velocity should not change. So this velocity, which is now thrown at this angle, has two components, horizontal, vertical. Horizontal component of the velocity has no reason to change, and that reason being acceleration. Acceleration in the horizontal direction is absent, it's only there vertical. So the horizontal velocity has no reason to change, but the vertical velocity will change, and that's what I want you to see. Look at the green horizontal thing, it is always a constant. Look at the green vertical thing, it is continuously changing again and again and again. Just observe this. Just observe this, guys. I wish I could change the background a bit. This background looks very, yeah, it is merging with it. But yeah, anyways, so you can see horizontal velocity is always the same, always the same. It's a vertical component which is changing, and it will uh, change because of the vertical acceleration. Everybody, till this point, is it clear? Okay, perfecto, perfecto. So, what are the different things that I can tell you in a projectile motion? Hmm. First of all, this is your initial velocity initial velocity or speed of projection. Speed of projection. It will have two components, u cos theta, which will be the x component. It will have u sin theta, which will be the y component, this being theta. This being theta. Ux is u cos theta, u sin theta is the y component. It will have some range, it will fall somewhere, that is the range. It will go up till some point, that is the maximum height. Tell me one thing, at maximum height, is the velocity going to be zero or not? Velocity, is it going to be zero or not? No, right? It won't be zero. In fact, the velocity will be minimum. Velocity will be minimum, and understand, the y component will become zero. The y velocity will become zero. Very, very crucial, guys. So if I show you the projectile like this, if I show you the projectile like this is from ground to ground. There will be one x component which will always be there. No matter what you do, it is always going to be there. It's always going to be there. It's the y component which will keep on changing. The y component initially will be this much, then it will become slightly small, then even smaller. Then the y component will become 0, then it will become negative, then more negative, and then back to even more negative. So this is how the y component will change. So vy velocity is not constant, as the acceleration in the y direction is negative g. But if you check the x direction, velocity in the x direction, velocity in the x direction is going to be a constant, since acceleration in the x direction is 0. Acceleration in the x direction is 0. And remember, since x velocity is constant, hence it will be just u cos theta. Hence it will be just u cos theta, which is basically ux. Which is basically ux. So this ux will remain constant throughout the journey. It's only the y velocity which keeps changing. Till this point, is it clear? Everybody with me? Everybody with me? Perfect. So now I'm interested in finding out how far it falls, how high it goes, how much time it takes to fall, and all these things. So let's start with maximum height first. Remember, we did these kind of derivations even in 1D motion. We're doing a similar thing over here in 2 dimension. I am interested in finding out what is this maximum height. I'm interested in finding out what is this maximum height h. So how do I find it out? I know one thing. At this particular point, it's the vertical velocity which is 0. It's the vertical velocity which is 0. Remember, the velocity is minimum and it is only Vx, which is basically u cos theta. U cos theta. Vy at this point is 0. Maybe I can use this. If I want to use this, maybe I will need an equation also in y direction. Which kinematic equation will I use in y direction? Which has velocity, final. S is ut plus half at square has time, out. V is u plus at has time, out. V square is u square plus 2s. Correct. We can use that. So how about using Vy square is uy square plus 2ay sy. So my dear students, obviously over here u sine theta, this is nothing but your uy in the y direction. In the y direction, initial velocity is u sine theta. What is the acceleration? Acceleration due to gravity is downwards. So the acceleration due to gravity is negative g. The displacement in the y direction is basically h. From here to here, y displacement is basically h. So h is the y displacement. Perfect. Everything should be fit in over here now. So Vy is basically 0. Initial velocity is basically u sine theta, square it, plus 2. Acceleration is negative g, displacement is h. Bring these people over here, so it will become 2gh is u square sine square theta. So h is u square sine square theta by 2g. That's the answer. That is the answer. Remember, in vertical motion, this sine square was not there. U square by 2g when it goes up and down. The only thing additional is sine square theta. That's all. So that's very easy to remember if you remember u square by 2g for vertical motion. Is that right? Awesome. Yep, very good, Alpha, Dhanishwaran, Harborine, third kinematic equation. Awesome. Proud of all of you guys. Moving on to the next derivation. Okay, what is it? Time of flight. How do I find time of flight? Okay. This entire journey, by the time it reaches here, the total time is t. What is so special about this point? It has landed on the horizontal line. That means the y coordinate is 0. The y coordinate is 0. In fact, the y displacement is 0. It started from here, it went up and it came down. The y displacement is 0. Do you agree with it? So maybe I need an equation in y direction only. Yep. And acceleration is downwards. So acceleration in the y direction is negative g. Initial velocity already known over here. This is basically your uy. Perfect. Maybe some equation in displacement. Third equation won't do because I want to find time. Second equation will be the most suited one. So how about using Sy is uyt plus half ayt square. Sy is 0. Initial velocity is u sine theta. Time is capital T plus acceleration negative g. Time t. So t square. Bring these gentlemen over here. So this will become gt square by 2 is u sine theta into t cancels. So gt by 2 is basically u sine theta. Therefore, t is 2u sine theta divided by g. Perfect. Guys, this reminds me of that formula for normal vertical motion. To just go up and come down, formula was 2u by g. Just add one sine theta over here. That's it. It becomes for the normal projectile. That's it. Awesome, right? And same things are valid over here too. Like for example, time taken to go up will be u sine theta divided by g. And similarly, the time taken to go down will also be just u sine theta by g. Both of them will be equal. Time taken to go up, time taken to go down, right? Symmetric motion. The motion is completely symmetric. Whatever happens while going up will happen while coming down. Just like in this diagram, whatever is happening while going up will happen exactly in the reverse order while coming down. That's it. That's the only difference. The order is reversed, but things which happen are the same. So the motion is symmetric. Lastly, we have the range. How far from the initial place will it land? I hit a 6 or I kick a ball. How far will that football go? That is basically the range. Okay. So my dear warriors, how do we do this? Let's think. To find the range, I think I should use this as my horizontal distance, which is the horizontal displacement. So Sx is basically the range. Displacement in the x direction is the range. So I need an equation in the x direction, which is that it is Sx is equal to ux t plus half ax t square. Sx is the range. This happens when my time is not any ordinary time, but your total time of flight. So this will be ux. Ux is u cos theta. Remember, ux is over here, right over here. I hope you can see this. This one is your ux, horizontal component of the velocity. Time, use it from the previous slide. This time will be useful from the previous slide, which is 2u sine theta by g. So use the time from the previous slide, which is 2u sine theta divided by g, and plus acceleration is negative g. So minus, I'll just put it on the next line, plus half into minus g into time square. That means 2u sine square theta divided by g, 2u sine theta by g whole square. 2u sine theta by g whole square. That's what it is. Now, what will you do? Just solve it. There is no other option. Yep, solve it. So what will you get? U into u is u square, and I can see u square is there here also. G and g square, 1g will remain below. So I can see u square by g is common in both of them. What is remaining here is sine theta, cos theta. I can see that. Sine theta, cos theta. Oh, but wait a minute. There is a small mistake over here. This is not even minus g. This is not even minus g. A lot of people probably just agreed to it this way over here. This is not even minus g, guys. This is wrong. This is ax. Acceleration in the x direction, how much it is? It is just a big fat 0. Perfect. So I don't have to put anything here. In fact, this whole term becomes completely useless. So then I just have one term remaining because acceleration is only in the y direction. So I just have 2 u square sine theta cos theta whole thing divided by g. But we know 2 sine theta cos theta is sine 2 theta. So it will become u square sine 2 theta divided by g. That is the final answer. That is the final answer. Is that right? You can use this also, but this is a much better looking formula. Yes. Got it, my dear warriors? Got it, my dear warriors? This equation which we have used here is in the horizontal direction. For the other derivations, we use the y direction, vertical direction. Why we used horizontal? Because we had to find range. Important thing to note, in range, the time value has to be put as the total time, which is 2u sine theta by g. Only then we get the answer. Also, keep in mind, acceleration is 0 because you are considering horizontal. This is not vertical. Hence, you will get the answer. Perfect. Now, there is a special scenario in this, which is about maximum range. Even before going for maximum range, let me ask you a simple question to you. What should be the angle? What should be the angle for maximum time of flight? And the next question for all of you, what should be the angle for maximum height? For maximum height in a projectile. What angle will you throw the projectile to get maximum time of flight? What angle will you throw to get maximum height? Come on. Pragnesh, probably I'll have to make a separate video on that itself. How to solve engage. Many of you are saying 45. Are you sure about it? Think again. Are you sure about it? Come on. Think carefully. Alpha is saying 90. Pakka. Why is alpha saying 90? What must be the reason behind it? Exactly, my dear warriors. Time flight. What's the formula? 2u sine theta by g. You want to make this guy maximum. Obviously, you will make sine theta as 1. When is sine theta 1? When theta is 90 degree. You will throw it obviously like this. Why will you throw it at an angle? Height formula is u square sine square theta by 2g. You want to make height maximum. You want to make sine theta as 1, which means again theta is 90 degree. So yes, the answer is 90 degree for both. The answer is 90 degree for both. But when it comes to range, you need to be really careful. The formula for range was u square sine 2 theta by g, which we just figured it out here. U square sine 2 theta by g. Okay. So if I want to make my range maximum, I need to make sine 2 theta as 1. That means 2 theta should be 90 degree. That means theta should be 45 degree. Correct. So for 45 degrees, the range is maximum. The maximum value of range, if you put sine 2 theta as 1, it will just come out as u square by g. That is the answer. So the maximum range is u square by g, and it happens at 45 degree. Correct. So imagine you kick a ball at multiple angles. Small angle, large angle, large angle, large angle, 90 degree. It will go in different curves. And how would they look like? They would look something like this. They would look something like this. Interesting. I don't know whether you can see it, but I will probably shade it properly. So when you shoot it at 45 degrees, it will go the farthest. But when you shoot it at a very small angle, maybe the range won't be so much. And if you shoot it at a complementary angle, let's say this is 10 degree, the complementary will be 80 degree. It will go up really high for a long time, but it will land up at the same place. Very interesting, guys. If you shoot it at, let's say, 30 degrees, it will go little bit farther, land here, stay in the air for a longer time. If you shoot it at an angle Complementary of 30, which is 60, it will go up even high, stay in the air for a longer time, but it will land at the same place. So for complementary angles, the range is same. Remember this. So for complementary angles, the range is same. The range is same for the same speeds. For the same speed, of course. And the range is maximum. And the range is maximum for 45 degrees. Range is maximum for 45 degrees. A very simple application of this could be a water spray. I'm pretty sure you would have seen it on a garden or on a lawn. It's attached to the ground and probably looks like this, and it ejects water at different angles. Some water will come here, some water will come like this, some water will go like this, some water will go like this, some water will go like this. Okay, it will spray water in different directions, and it will make that particular floor or that lawn wet. Correct? It will make that lawn wet, and it will keep rotating in different directions. You might have seen zoop zoop zoop, it keeps spraying. So there is a maximum limit till which it can spray, and that is basically R max. That is basically R max. And if this thing rotates, the maximum range also needs to be rotated. So it will basically wet the lawn in a circular form. So the area which is watered, so the maximum area which is watered will be pi, but into the range which is there will become the radius. So R max squared. The maximum area which is watered will become pi R square, radius will become the maximum range. Imagine such a beautiful application of this. Okay, very nice. Let's move on. Can we make the angle from 0 to what is it, alpha? 0 to, am I not able to see it? 0 to 45 degrees for lesser water usage? Yes, you can keep it 0 to 45 degrees for lesser water usage. What a thought, alpha. Because anyways, after 45, it's going to repeat itself. So yes, you can just keep it 0 to 45. Correct. What a brilliant thinking. Loved the way you thought. Now comes the equation of trajectory. What is this equation of trajectory? In general, the word trajectory means path. What does the word trajectory mean? It means path. So I might have a particle and it is going along this particular path. So the path taken by a particle is called trajectory. So then what is the meaning of equation of trajectory? Equation of trajectory means nothing but a function of their coordinates without time. A function of their coordinates without time, that is basically called equation of trajectory. So maybe the particle has some x coordinate, some y coordinate. So the y and the x coordinates or the z coordinates are related to each other. That equation is called equation of trajectory. For example, I tell you, the x coordinate is 2t and the y coordinate is t raised to 4. Okay, this is the equations of the coordinates. I ask you, what is the equation of trajectory of the particle? I ask you, what is the equation of trajectory of the particle? Yes, I'll be doing inclined plane projection also. How many times to tell this? What it means is you just need an equation in the coordinates, no time in it. So eliminate time. So what is time? Time is basically x by 2. So use this time here. So y is equal to, instead of t, put it as x by 2 and whole raised to 4. That's it. This is your equation of trajectory. Y is equal to x raised to 4 by 2 raised to 4. So it will be x raised to 4. 2 cube is 8. So this will be by 16. So this is the equation of trajectory. As simple as that. Any equation of trajectory means eliminate time. I can give you one more example. Imagine I tell you x is equal to t square and y is equal to 5 cos t. What is the equation of your trajectory? Somehow you have to eliminate time. Look at this. Since x is t square is x, therefore t is basically your root of x. T is basically your plus minus root of x. Is that right? Use this time over here. That means y is equal to 5 cos, instead of t, put it as plus minus root of x, but cos of minus theta is cos theta only. Therefore, y will be equal to 5 cos root of x. This is your equation of trajectory. As simple as that. Eliminating time. Simple? Understood? Clear? Shall we go ahead? Are you smashing the like button? If you have forgotten it, please do that right now. If you have forgotten to subscribe, subscribe right now. It's very important you do that. Yes, don't forget to like, subscribe, all these things, basic things. Cool. So now, when I want to find the equation of trajectory of projectile, we'll eliminate time, as simple as that. So I need x coordinate and the y coordinate separately. So let's see. X coordinate. For that, I will write Sx is uxt plus half ax t square. At any given instant, that particle will have some x coordinate and it will also have some y coordinate. Okay. So that point at some time instant while it is going on. Okay. So what is the x coordinate? It will be the x displacement. How much ever I have moved in x, that is also the x coordinate and the x displacement. Initial velocity in x is u cos theta. Time is t. Acceleration is 0. Remember that? Acceleration in the horizontal direction, not there, only in the vertical. So therefore, from this I get time as x divided by u cos theta, which I will substitute it later on somewhere. Let's go to y direction and let's write down Sy is equal to uyt plus half ay and t square. Y direction, how much is my displacement? It is the y coordinate itself. So therefore, I'll just put y. What is uy? It is u sine theta. What is t? Oh, it is here. Just have to substitute x by u cos theta. Over here, and plus acceleration, that's negative g, and time, just substitute this. So x by u cos theta, but you have to square this. So what will you get? Y is equal to u cancel, sine by cos is tan, so x tan theta minus g x square by 2 u square cos square theta, by 2 u square cos square theta. I'll rewrite it on the next slide. That will be better. Hold on. So the equation that I have got is as follows. Y is equal to x tan theta minus gx square by u square cos square theta. Now this is a formula which you are supposed to remember. X tan theta minus gx square by 2 u square cos square theta. Sorry, I forgot the 2, my bad. Yeah, 2 u square cos square theta. But there are some interesting things which you will see from this equation. So to see those interesting things, I'll just manipulate this equation a little bit. What I will do, I'll write it down like this. I'll write down this guy first. So minus g by 2 u square cos square theta, okay, into x square. Then I will put x into tan theta, and then I will put plus 0. Why did I do it like that? Because it is easily comparable to y is equal to ax square plus bx plus c. What is this? This is a quadratic equation. This is a quadratic equation. So hence, even this is a quadratic equation. Quadratic equation in x with with no constant term. With no constant term. Which means the graph must pass through the origin. And it is passing through the origin, which is a big thumbs up. Perfect. Second thing, the graph has to be, the path has to be a parabola. And not just any parabola. I mean, look at this shape. This is a parabola, definitely. Just look at the a value, the coefficient of the square term. It is negative. So it must be a downward parabola. Downward parabola. Why is it downward? Because a is negative. The coefficient of the square term is negative. Brilliant. So we just proved that the path taken by a projectile is a parabolic path with no constant term provided you start from the origin, and it is a downward parabola. Amazing. This is the proof for it, right? Amazing. You can also rearrange this into this format where R is the range. Okay, it's one and the same thing. If you substitute the range formula, you will again get back the same thing. So you should remember both these forms. Both these forms are very, very important. Okay, so this is the equation of trajectory because it does not have any time in it. You give me where it is, I will tell you how high it is, or you tell me what is the height, I'll tell you where it is, basically x. So can be very, very useful. So let's have a look at the summary report, main things. Okay, there are some important things which are generally asked in many times in many places, and many books you will see, many PYQs you will see has these two problems in common, where you throw a projectile at some angle and then you throw it at a complementary angle. Obviously the ranges are same. The range is same for complementary. For every angle, the time and the height will be different, correct? If smaller angle, smaller time, smaller height, more angle, more time, more height. You will see that the product of times will be 2r by g, product of height will be r square by 16. I want you to prove this as homework. As simple as that. The answer is already given. I'll give you a hint. Put the value of time, 2u sine theta by g. Second time will be 2u sine 90 minus theta by g. Sine of 90 minus theta is cos theta. Use that and you will get the answer. Okay, so this is something which you will do it as homework. Cool. Give me a thumbs up quickly. I want everybody to, even who have or who are watching this as recorded, write it down in the comments. Sir proved. Sir proved. Sir done. So that I know you have reached this point of the lecture and you are able to get this with very simple steps, very simple formulas. You are going to get this, guys. So it's not at all difficult. Shall we go ahead? Shall we go ahead, my dear students? Okay. So now that we have reached here, just one second, and let me just drink some water. Let's take a 2-minute water break quickly and come back. I just take a 2-3 minute water break. I'll just come back. I'll just water. We'll do projectile on a height and projectile on incline. These two things are remaining. We'll just do that. Hello, hello. Am I audible, visible, guys? Shall we get back to our business? Okay, okay. Let's get back to our business and let's start with some questions. Ready for it? Oh, there was a poll which was being conducted. Class 11th, 12th, repeat and drop. And what do we have the percentages as? We have almost like 36% are 12th standard, almost close to 30% 11th, repeat drop 24%. So a lot of students for 2025. That's almost 60%. Others, who are these others? Teachers or younger students? So mixed crowd. Great. Very good. Chalo, let's begin with the class, my dear warriors, with some questions. Here is the first level question. Ball is thrown from a field with a speed of 12 at an angle of 45. What distance will it hit the field again? Okay, so it is thrown at some angle of 45. It will hit the field again. Basically, what they have asked is the range. What they have asked is the range, as simple as that. So for that, use square sine 2 theta by g. That's the formula. What is the speed? Speed is 12, so 12 square. What is sine of 2 times of 45, which is sine 90, which is 1 basically. G is basically 10, so it will be 144 by 10, which is 14.4 meters. So it will hit the ground back after 14.4 meters. Correct. Awesome. Shall we go to the next question coming up on your screen? Very straightforward question. Level 2 question. Let's go straight to some good level questions, or else it will be just substituting. Although I had seen one more question where it was asked, this is again level 1, where it was asked to find max height when range is maximum. When the range is maximum. Let's say it is R. This was also a very interesting question which I had seen. So first of all, for maximum range, we know theta is 45 degree. In fact, that maximum range comes out to be u square by g, sine of 2 times of 45. Sine of 90 is 1, so it will just be u square by g. That's the maximum range. What is the height when the range is maximum? What's the height when the range is maximum? Height formula is u square sine square theta by 2g. So this will become u square by 2g. Theta will now become 45. It will become sine square 45 degree. Sine 45 is 1 by root 2. So it will become 1 by root 2 square. So root 2 square is 2. 2 2s are 4. So it will become 1 by 4 u square by g. But wait a minute. What is this term u square by g? U square by g is basically range. So range by 4 is basically the height. So that is the relation. So the maximum height is range by 4 when the range is maximum. Amazing. So this was a very interesting problem which I had seen. I just remembered, thought of doing it. Let's do the next question. This was asked in JEE 2023. Projectile is fired at 30 degree. It is at the same height at 3 seconds and 5 seconds. The speed of the projectile is how much? This was one of the brilliant question. There is a small trick, I believe, in this question. So say this is the ground level. Say this is how the projectile is fired and it goes and hits here. It's at the same height at 3 seconds and 5 seconds. At 3 seconds and 5 seconds. So probably I just draw a line parallel like this. 3 seconds if it is over here, and 5 seconds is it over here. Understand that if it takes 5 seconds to go from here to here, it will also take 5 seconds to go from here to here by symmetry. Everything is symmetric, correct? So if it takes 5 seconds to go from here to here, it should also take 5 seconds to go from here to here. I hope this is very, very clear. So if this is 5, even this is 5. And we just saw over here, it is clearly mentioned, it takes 3 seconds to reach here. That means from here to here, that means from here to here, the time taken was 3 seconds. From here to here 3, from here to here 5. So what would be the total time? What would be the total time? 3 plus 5, which is basically 8 seconds. Isn't this amazing? The logic that we used? Clear? Everybody? Till this point? I'll just repeat. From here to here, it was 5. So if I reverse it, mirror image, from here to here will also be 5. But from here to here was 3. So the total will be 3 plus 5, which is basically 8 seconds. Perfect. So 8 seconds is basically the total time of flight. And total time of flight has a formula 2u sine theta by g. So 8 is 2 into u, I don't know. Theta is given to be 30, sine 30 by your 10. 2 goes with 8 4 times. Sine 30 is basically half. So that 2 goes over here. So 2 into 4 and into basically this 10 is u. So basically it is 80 meters per second. 80 meters per second. Perfect. That is the answer. Got it? How many of you loved the question? How many of you loved the question? This was asked in JEE 2023, my dear warriors. JEE 2023. Yes. What a brilliant previous year question. Cool. Shall we go ahead to the next one? Okay, let's go to the next one. Coming up on your screen. Here it is. What does it say? An object is projected in air with an initial velocity u. The motion is such that the range is maximum. Another object is projected with a range half of the first object. The velocity remains the same in both the cases. Then the angle of projection at which the second object is projected. This was asked in JEE 2022. This is a level 2 question. This is also a brilliant question. Let me tell you that. So what do we do over here? Okay. The range is R and is maximum. For this particular part, theta will be 45 degrees and that range will be u square by g sine of 2 multiplied by 45. Sine 90 is 1. So therefore R is u square by g. Now there is another particle whose range is half the range of the previous one. So if the range is half, if I just put R by 2, which will be u square by g, and the angle is unknown, some new angle. Just substitute this R from here. Just substitute this R from here, which is u square by g. This 2 is there as it is. This is u square by g. This is sine 2 theta. U square by g cancels. So sine of 2 theta is basically half. Whose sine is half? Obviously 30 degrees. So therefore, what is theta? It is 15 degrees. So we got the answer. The angle at which it will be projected will be 15 degree. But that is why this is a previous year question. The answer is not 15 degrees alone. Remember, complementary angles, range is same. Range is going to be same. So there are two answers for it. One answer is 15 degree and the other answer is 75 degree. This is also correct. This is also correct. 15 degree and 75 degree. A lot of people only write the answer as 15 degree, but that is not the only correct answer. That's why it's a previous year question. Two answers are there. Okay, 15 or 75. Next question. This was asked in 2011. This is level 3 question. Let's see if you guys can figure it out. Read the question on your own. Take a moment to draw the diagram. A train is moving in a straight line with some acceleration. A boy is standing in the train, throws the ball forward with some speed at an angle of 60 degree to the horizontal. The boy has to move forward inside the train to catch the ball back to the initial height. The acceleration of the train in meters per second square is how much? Read the question again. Read the question again. You will understand is asked. what is given. Draw the diagram. Maybe you will get some idea. Maybe you will get some idea. Come on, my dear warriors. Think about it. What should be the starting? What should be the point for this? A train is moving along a straight line with some acceleration. Boy throws a ball forward with some speed of 10 at an angle of 60. Boy has to move some distance inside the train to catch the ball back at the initial height. The acceleration of the train is. Think about it. What will you do? What will you do? I think there are two things in this problem. One is the horizontal, one is the vertical motion. So let's think about it properly. So this is the railway track. This is the train. I'm not showing the complete part of it. And this ball was thrown like this with some angle at some speed inside the train. So the ball will go and fall somewhere over here. Meanwhile, the train is also having some acceleration. Interesting. Now you have to take the motion into two parts. Just consider the vertical motion first. Let's just find how much time the ball stays in the air first. Let's just find out how much time does the ball stay in the air. Then we will do the horizontal part. Because time for which it moves and all that is not given. So, in the y direction, displacement in the y direction is u by t plus half a y t square. Y displacement, because I go up and come back, it should be a big fat 0. Initial velocity in the y direction 10, 60. So this is 60, so this will be nothing but 10 sine of 60 degrees. If this is 10, this will be 10 sine 60 because this angle is 60 degrees. So I'll just put over here 10 sine 60 degrees. Time I don't know, plus acceleration is negative 10 and t square. Bring these people over here. 10 by 2 is 5, so 5t square will be 10 sine 60 is root 3 by 2 into t. T cancels. 2 goes with 10, 5 times, 5 also cancels. So t will be basically root 3 seconds. Time will be basically root 3 seconds for which it stays in the air. Okay. Now the next part. Train is going, boy is standing inside the train moves forward, angle is also given, the boy has to move forward inside the train to catch back the ball at the same height. What should be the acceleration of the train? When you throw it at an angle, obviously the ball will fall in the front. But you cannot use the range formula anymore. You know why? You know why you can't use the range formula anymore? Because reason being, when the ball leaves your hand, remember the train beneath it is accelerating. So, from the perspective of the train, the ball is accelerating behind. I'll repeat. When the ball leaves the floor, leaves the hand of the person, the train beneath accelerates at some meters per second square. So if the train accelerates forward, the ball appears to accelerate backward with the same acceleration. Do you guys agree with this point or no? Yep. So there is acceleration in the x direction as seen from the perspective of the train. So I can't use my range formula because the range is only applicable when the x acceleration is a big fat 0. That is why it is a level 3 question. Got it? So let's try to think. What do we do ahead? Let me just create a duplicate of this. Time I just got it as root 3. Okay, no issues. So now I'm going to sit in the perspective of the train. This ball, which has been now thrown over here, has now a new acceleration in the backward direction like this. Let's say this is A. And this ball goes like this and falls over here. And this distance is given to be how much? 1.1 1.15 meters. 1.15 meters. This is what is given. So now let's use what? X direction motion. This is 60 degrees. This is 10. So let's use in the X direction. In the X direction, Sx is equal to ux t plus half ax t square. Half ax t square. X displacement 1.15. Initial velocity in the X 10 cos 60. Time, we just figured it out, it was a root 3. It was a root 3 plus half. Acceleration is in the negative direction, so minus a into time. Time was root 3, so root 3 square. That's the equation that I will use. This understanding of this diagram is very, very important, else you will get completely wrong answer. Now you just solve it. 1.15 cos 60 is half, so it will become 5 root 3. Okay, and this will become minus, this will become root 3 square is 3 by 2, and a over here. We just solve this now for a, so this will become 3a by 2. 3a by 2 is basically 5 root 3 minus 1.15. Solving this, you will get the value of acceleration, which comes out to be close to 5 meters per second square. Close to 5 meters per second square. Okay, after solving. What brilliant question, because it involved two different concepts. One in the y direction, you had to solve it and then understand that, okay, in that time, what is happening is the train accelerates beneath it, so the ball accelerates also behind. So I need to consider some x direction acceleration. That was a major catch in this problem. That's why it is a very tricky level 3 question, which was asked in JEE 2011. Loved it? Awesome question? Perfect. Perfect. Okay. Now let's slowly move on to projectile from some height. Let's move on to projectile from some height. These are the last two major concepts. If you throw something from a height, it's very similar to dropping something. So I think I have the diagram for it. Hopefully, yeah, it goes like this. You throw a ball something like this, you will see after some time it lands somewhere over here. Okay, it goes something like this and hits somewhere. So we are interested how much time it takes, how far it falls, with what speed will it fall, and all sorts of things. In any of these projectile problems from a hill, keep certain things in mind again. If I throw it like this, then it is called as a horizontal projectile from a hill, because I'm throwing it horizontally. But sometimes you might also throw it at an angle. That's okay. Even if you throw it at an angle, you can always split it up into two components. One will be the x component, which will always stay with you, and it will never ever cheat you, because it will never ever change. It will be always constant. So the x component will always be equal to the initial x component. It will be constant. Reason for that, there is no acceleration. The only thing that will change is the y direction velocity. It will become slowly less. It will become probably even 0, and then it will start increasing in the other direction. That's what is going to happen. So you will get Vy, which is obviously not a constant, because acceleration in the y is negative g. That's all. That is something which you should really understand over here. So that is a reason why initial velocity, final velocity, everything will be different over here, and probably it will hit the ground also with a very different velocity. The velocity will also be different. So we are interested how much time it takes, how far it falls, what speed it hits, all these basic things. All these basic things. Okay. So let's derive the formula, guys. It is not that difficult. I hope I have the slide. We have to find the time. How much time does it take to hit the ground, assuming it is thrown horizontally? This is very important. I have thrown horizontally. If I throw it at an angle, then the derivation will change. You have to basically use kinematic equations, no doubt about it. So I will just mention over here, use kinematic equations in x and y separately to solve all these questions. There is no other option. There is no other alternative. You have to use kinematic equations. So if you want to find the time, what do I do? Okay, let's think. Initially, it was horizontal. I know how much it moves down. I don't know where it lands. I want to find when it lands. I know how much it moved, but only in the vertical direction. So maybe y direction is something which we need to focus on. Okay. Displacement in the y direction, how much it is? Check this out. From here to here, when it went, it has moved down this much. It has basically moved down this much. This is the displacement in the y direction by the time it reaches here. This is final, this is initial. So it is basically minus h. What is the initial velocity in the y direction? That's 0 because the velocity was horizontal. There is no vertical component. Perfect. Acceleration in the y direction, that's negative g. Very nice. So let's solve the equation. Which equation? S is ut plus half at square. S is ut plus half a t square. Sy is minus h. Uy 0 plus half into acceleration negative g, time total time, right? Minus minus cancels, minus minus will obviously cancel. So h will become gt square by 2, or rather t square will be 2h by g, rather t will be root of 2h by g. This sounds very familiar to me. This sounds very familiar to me. This was also the time when you just drop a ball. And why is it that the answer is same? We should probably think about it. See, my dear warriors, if you just drop a ball, if you just drop a ball from here, slowly the velocity will increase like this before it hits the ground. Before it hits the ground. If suppose you throw it with some speed like this, it will go somewhere here, but the vertical velocity will exactly increase the same way as this guy. The vertical velocity will exactly increase the same way as this guy. In fact, you throw it with a very large speed, no issues. It will probably land somewhere over here. It might land very far away. That won't change the fact that the vertical motion remains unaffected, because whatever you have done is only in the horizontal direction. Vertically, still initial velocity is 0, acceleration is same, displacement is same. So all these things you will see the time taken is the same. The time taken is the same, and it is basically root of 2h by g. What is the reason for that? Initial velocity 0, acceleration negative g, displacement minus h. All these terms are same. Why won't the time be same? As simple as that. Got it? Very interesting. So that's why the time is same. But what might be different is obviously the final speeds, because these initial speeds are different. Yeah, the final speeds would be definitely different. What about the range? Well, if I want to find the range is basically this one. Range is basically this one, my dear warriors. I will have to probably think of it as from here, initial to final, it has moved this much. This is the horizontal displacement. So I will use Sx is ux t plus half ax t square. Horizontal displacement is the range. Ux is just u. Time we just figured out, capital T. Acceleration is a big fat 0. Remember, there is no acceleration in the vertical. It is only there in the horizontal. So acceleration is a big fat 0. So this term vanished. So therefore, range is u into t. If time is not mentioned, then you can substitute it from here, which is nothing but root of 2h by g. That is the formula for the range. U root 2h by g. Simple, straightforward. Okay. How to complete a chapter full-fledged without any doubt? for JEE. Vasu, others, droppers, everyone, please see, guys, you're not watching all the videos which I'm making on the channel. This is not at all done. You are just watching the videos, academic classes. You are not watching my strategy. If you have missed it, please watch it. See, one thing I've given, how to complete the entire syllabus for droppers with a timetable, complete analysis specifically for droppers. This is for droppers. Next important, month-wise plan and proper action plan in general for JEE 25, including problems, including chapter completion strategy, syllabus completion strategy is mentioned in this video. If you want, sir, the list of the chapters also you give me, sir. Okay, that also I have given you. No issues. See, over here. Full syllabus in less time, 11th and 12th chapters, which you can study them together. Okay, in relation with each other. So that also I have mentioned over here. Okay, so these 3 videos, watch it as per your need, my dear warriors. It will be very, very useful. Cool. Everything has been mentioned. See that you only yourself will be confident that yes, I can do it. Vasu, if you're not a dropper, except for the dropper video, the other 2 videos are for you. Okay, for the other 2 videos are for you. Can we use the previous formula and divide by 2? Yes, Drew, you can do that. But tell me one thing. Do you know this speed? I don't know that. Do you know this angle? I don't know that. This speed and this speed won't be the same because the speed will reduce. That's why a lot of people, they ask me, sir, can't I just take this and multiply 2 times or divide 2 times and all that? Yeah, you can do that. But problem is I don't know this angle also. I don't know this speed also. So you have to ignore it. Right? Hello, Prakateshwar. Yep. Vasu, this is clear. This speed of impact. Speed of impact is very straightforward. The vertical and the horizontal have to be dealt separately. The x component will be constant since there is no acceleration. Therefore, the x component will still be u only, which is basically this one over here. The problem is only for the y component. Initially, the y velocity is 0. Finally, there will be some y velocity. That y velocity, I can do it like this. Vy square is uy square plus 2ay sy. Initial velocity 0. Acceleration negative g. Displacement minus h. Minus minus becomes positive. So it becomes 2gh under the root is vy. Perfect. But maybe I want to find the total speed. Maybe I want to find the total speed over here, which is v. So then that total v will be root of what, guys? Vx square plus your vy square. That's it. So substituting both of them, substituting vx and vy over here, what do I get? I will get vx square is basically u square plus vy square is 2gh. Root will go off. That is the answer. That is the speed with which it falls at an angle. This will be for hitting it at some angle. Please mind it. Yeah, you can use the third equation. Correct. Perfect. Awesome. So these are the main things which are there in horizontal projectile. If it is not horizontal, like I mentioned here, use kinematic equations. No other option, no other alternative. You have to use it. Okay, so let's go to some questions coming up on your screen. What do we have? Directly level 2, no issues. A body of some mass thrown horizontally from the top of a tower of height h touches the ground at a distance of 100. Now the mass is made 2m, velocity is made half, tower height is made 4h. What will be the ground distance? First of all, you should realize in this entire problem, there is one piece of data which is useless, waste, unnecessary to confuse you. And that is nothing but the mass. Because acceleration due to gravity, motion, kinematics is independent of that mass. So why bother about it? It is chumma given to confuse you. Don't waste your time there. So ignore that, read other things. It's all about the range, right? Height h touches the ground at 100 meters. What is the range formula? U root 2h by g. This range is basically 100. This is u root 2h by g. Perfect. Second scenario. In the second scenario, when the velocity is v by 2 and the height is 4h, so there will be a new range, I'll call it r prime. Speed will be u by 2. Height will be 4h. Height will be 4h by g. Root of 4 is basically 2. Root of 4 is basically 2. Okay, so I'll have 2h by g. 2 cancels. So I'm left with u root 2h by g. Oh, wait a minute. U root 2h by g is 100. Oh my god, this is just 100. What are we fooling? Who are we fooling? So the new range is also going to be 100. This was a JEE Mains 2024 question. Okay, the answer is not mentioned here, but yeah, the answer is 100 meters. It's the same. It has not changed. Simple, easy peasy, lemon squeezy. Can we go ahead? Okay, let's move on. Let's move on. Projectile is fired horizontally with some speed from a hill. Find the time taken, the distance from the foot, velocity with which it hits. All three formulas just substitute, guys. Nothing great in this problem. But I think because 98 and 490 is given, I think they should have also given the value of G to be as 9.8, or else you will not get good answers. Okay, so first thing is time taken to reach the ground, which is root of 2h by g, which is root of 2 times height 490 divided by 9.8. 490 into 2 is basically 980 by 9.8, which is basically root of this will be what, 100 times, which will be basically 10. Yes, which will be basically 10 seconds. Everybody with me? Let's check the answer. Yes, 10 seconds. Perfectly correct. Similarly, you can solve the other things also. The distance, basically the range, is the speed into time. Horizontal speed is 98 multiplied by time 10. So it will be 980 meters. That's the range. Let's find that out. Yes, 980 meters. Perfectly fine. Speed, that also no doubt we can find it out. I had just told you the final speed is root of u square plus 2gh. U is nothing but 98 plus 2 into g into height. Height is 490. 490. So this is 98 square, right? U square plus 2gh. Perfect. So 490 into 2, or rather 490 into 2 is basically 49 into 2 is 98. So we can just see 98 is again common over here. So this will be something like 98 and 98 plus. You will see this is 10 here, 10 here. This is nothing but 100. Yep, perfect. So this is what you will get as the answer, close enough to basically, 2 times of uh, the same. Yeah, 98 and 100 are very, very close to each other. You can see that 100 and 100 very, very close to each other, 100 and 98. So you can just write it as 98 only instead of writing it as 100. So very, very close to 98 root 2. Fair enough, no issues. Cool, as simple as that. Let's move on to the next question. This is level 3 question. At some time from the origin, a particle follows a two-dimensional trajectory in xy plane so that the coordinates are given by some equation. Wow, interesting. This was JEE Advanced 2020 question. X and y components are ax and ay respectively. The question is the following. Read the options carefully, guys. Read the options very, very carefully. One or more options may be correct. One or more options may be correct. One or more options may be correct. Come on. The particle speed from the origin is 1 meters per second. Particle follows a two-dimensional trajectory y is equal to x square by 2. The acceleration components are ax and ay. If ax is equal to 1 implies when the particle is at the origin, ay is equal to 1 meters per second square, ax is 0. Guys, just think about it. This is a quadratic equation, first of all. Quadratic in x, and there is positive square term. That means the path will be like this. The path will be basically like this. And if I show the axis, this will be the y-axis, this will be the x-axis. That's how it will look like. 100%. I can compare it with projectile motion. In projectile motion, it was a downward parabola. Now it is upward parabola. So 100%. Don't you see that the acceleration must be like this only in the y direction? In fact, there will be no x acceleration. There will be no acceleration only in the x. So acceleration in the x is 1 is 100% wrong. A option goes wrong. Ax is 0 seems correct. Okay. Ax is 0 again seems correct. So do you understand why there is no acceleration in the x? I realized it comparing it to the quadratic equation of a projectile. Okay, perfect. What about other things? X is 0. What is the acceleration? Okay. At t is equal to 0, particle's velocity points in the x direction. This is very straightforward. At time 0, the velocity v0 points in the x direction. Yes, this is correct. And this is correct. So C option is 100% correct. Okay, I think we can do this. What is the y direction acceleration? We can do this. How do I find out the y direction acceleration? Right? That is something which we need to figure out. I know the speed initially is 1 meters per second. Okay. So in order to find the y direction acceleration, can I compare it somehow? Can I compare it somehow? Think about it with something. Okay, I know what we can do. I know what we can do. Let's go to x direction first. In the x direction, there is no acceleration. Initial velocity in the x direction is 1. Acceleration is 0. So displacement will be x coordinate. So using the equation Sx is equal to uxt plus half ax t square. X will be equal to ux is basically 1, time don't know, plus ax is 0. So hence x will be t. This is one simple thing which I am getting. X is basically t. Now let's go to the y direction. Observe this. Sy will be uyt plus half ayt square. This displacement in the y direction will be the y coordinate. Initial velocity was 0. Look at it. There was no velocity in the y direction. It was completely in the x direction. Plus acceleration in the y direction, I don't know. Time from here is basically x. So x square. So now what do I get from this? What do I get from this? Y is equal to ay x square by 2. Ay x square by 2. Compare it with this. Y is equal to x square by 2. Hence comparing, what do I get, my dear warriors? I get immediately ay is 1 meters per second square. Compare this with this. Everything is similar. Ay is there, ay is absent, so ay must be 1. Number 1. How to choose the initial point in the parabola? It is mentioned right over here. It is mentioned right over here. T is equal to 0 from the origin. T is equal to 0 from the origin. That's how I know. And if you put x as 0, y will be 0. That's how I know it is there. Understood? Awesome. Now that I have got it, ay is equal to 1 meters per second square, implies ay is 1 at all times. I think this is something which I can mark. Obviously, I can mark this. Last one. At 1 second, angle between the velocity and the x-axis. So we can find the velocity. It is not a big deal at all. So this velocity was constantly 1 meters per second because it was given. In the y direction, Vy will be uy plus ayt. Uy is 0, acceleration is 1, time is 1 second. So Vy is also 1 meter per second. Oh, perfect. So after 1 second, the y velocity is 1. The x velocity is also 1. So hence the resultant velocity will be making an angle of 45 degrees, magnitude root 2 meters per second. Magnitude root 2 meters per second, which is option number D. So B, C, D should be correct. Yes, it is correct. That's all. Nice question. Loved it. Shall we go ahead? Everyone with me? Love the question. So we are solving all kinds of questions over here, my dear Alliance. All kinds of questions. This is the best series. Forget Hindi channels or English channels. It's not about that. It's about the best content on YouTube. So if you are really serious about JEE, follow this series. You will see a difference in yourself within the next couple of weeks, next couple of months. And that's what JEE English stands for. Let's do projectile motion on a plane. Last part. This is more specifically towards advanced. Unfortunately, I cannot show the simulation over here. I don't think I can change the angle, which there comes a nice, probably modification in this where I could tilt the ground over here. But I'll tell you one thing. I'll tell you one interesting thing. What is the meaning of projectile on an incline? Okay, let's just probably reset it. Let's just fire it as before. Okay, just 1 second, reset it again. Okay, let's fire it like this. This was a normal projectile, right? Now just imagine somebody decided to construct a ramp or an incline like this. Somebody decided to construct a ramp or an incline like this. What will happen to the projectile motion? This projectile motion will still continue its journey like this, only to be stopped over here. It can't do this part, but still it is doing its parabolic motion. It is still doing its curved motion. It's still following the same equation. It's just that it is not going to continue beyond this point. So look at projectile on an incline as a projectile which is interrupted in between. That's all. It's just a projectile which is interrupted in between. That's it. It will still continue. It just stops. After this, don't see. That's all. Imagine if I dig a pit over here, this will continue its journey below. So it will go up and continue its downward journey. So that will be a projectile down the incline. This would be up the incline, up. It's up. So that's why up the incline. I go like this. I dig a pit. It will continue its journey. It won't stop here. It is projectile down the incline. That's it. That is what it is. That is what it is. So let's go back. Let's go back. This is one way of looking at it. So projectile up the incline and projectile down the incline. Now there are two scenarios which we have to deal with. So I'll just write down two methods. Method 1 is where this is your same level. So this was your projectile. So if you continue the journey from here to here, this is your up the incline. Whereas if you continue the journey uninterrupted till here, that is down the incline. Usually, you know the time of flight till this point. You know the time of flight till this point. We will be seeing the formulas for time of flight down the incline. Also, the time of flight up the incline. Not just that, we'll be also seeing the range up the incline. When I say range up the incline, it is basically this particular distance, range up the incline. We'll also be seeing the formula for the range which is there down the incline. Range which is there down the incline. Is that clear, everyone? This would be the normal range. This would be the normal range till here. Can you quickly guess among all the three ranges and among all the three times, who will be the largest, who will be the smallest? Quickly answer in the chat box. Quickly answer in the chat box. Vasu, the best ways to logical thinking is basically solve riddles, solve puzzles, number one. Number two, never look at the solution so easily. Always try your best. Number three, start from easy, go to hard. Number four, use a good book which promotes logical thinking rather than telling you this is the type of problem, this is how you do it, which is what most likely Cengage does most of the times. That's why I say that Cengage does not promote logical thinking, although it's a very good book. Okay, H.C. Verma is a book which promotes logical thinking, right? 𝙾𝙪𝙥𝙤𝙪, so many other books are there. So that is one thing. And the last thing, very important, is basically a right mentor, a teacher who teaches you like that rather than that rote way. I mean, even if you learn from some teacher like that, maybe you'll get 90, 95 percentile, 96. You will be like, oh, the teacher helped me a lot. I got 96 percentile. But the teacher will never be able to push you to 99.9, 99.8. And also beyond that, a lot of students still message me, sir, whatever you taught is useful for me. Even inside IIT, there are these students who came from a particular institute who studied 7 to 8 hours in coaching from morning till evening, and they are not able to solve these questions in the first year of IIT. They got better ranks than me or same ranks than me, but their logical thinking is not developed, sir. Why? Because from morning till evening, these coaching institutes just made them write the same problem again and again. This type of problem, solve it like this. That type of problem, solve it like this. The teacher scold them, you have to do these many problems. But our way of teaching, my way of teaching is way different, guys. I mean, it's not about that. It's not about spending 7 hours. There was a student of mine who used to go to school, who used to go to coaching, obviously my coaching, and then apart from that, participate in debates, okay, in the school. And in spite of that, he barely got 3-4 hours every day, and he got all India rank of 120s. Yes, that is the rank, not in mains, in advanced. So it's all about how you study, the mentorship, the books, the level of questions, how you increase, and all of that. Okay. I'm so glad, Arvinda, you got a seat in VID Vellore, and I'm pretty sure you're going to rock it through. Okay. Now, there is another way of looking at the inclined plane projection, and that is also something which I want you to see. Observe this. Under normal circumstances, our projectile goes like this, and we say that, hey, listen, that the x velocity is basically constant, and the x acceleration is 0, and the y velocity keeps changing, becomes 0, and then it becomes negative. So y velocity is not constant because the y velocity acceleration is there. This is normal circumstance. Now, when you look at inclined plane, when you look at inclined plane, let's say I look at up the incline, tilt that diagram, or just look at x-axis and y-axis like this. This is your x-axis and this is your y-axis. And your projectile is now going like this. Projectile is now going like this. Now, acceleration due to gravity is down, and now it has two components. That is the interesting part. Here, our entire acceleration due to gravity was exactly downwards. But now, the acceleration due to gravity will have two components, one component here and the other component over here. Because acceleration is down, there will be two components along y and x axis, and you can see how much it should be, because if this is technically g and this is that particular angle of inclination alpha, this component would be basically g cos alpha, and the other component will be basically g sine of alpha. So there is acceleration in x as well as y. There is acceleration in x as well as y. In fact, you would say that the x acceleration is negative, because this is x-axis, it's opposite, negative g sine alpha. Okay, remember, this is your x-axis, this is your x-axis, this is your y-axis, and you will say that the y acceleration is negative g cos alpha. So there is acceleration in y as well as in x, which also means that the y velocity will obviously not be a constant. Not just that, even the x velocity along the incline won't be a constant. That is the only difference. So x velocity is not constant, and there is acceleration in x and y both. Clear? You do the exact reverse for down the incline. This is your y coordinate, y axis. This is your x coordinate. Imagine your projectile being thrown like this. It's going and hitting somewhere here. Your actual acceleration due to gravity is somewhere here, g. You will split that g, assuming this is alpha. You'll split that g into two parts. One is over here, which is g cos alpha. So your ay acceleration will be minus g cos alpha. And the other component will be over here, which is g sine alpha. So the x component of the acceleration will be plus g sine alpha. That's the major difference. So again over here, the x component of the velocity won't be a constant, whereas over here the y component of the velocity also won't be a constant. It's only here that the x component remains constant, whereas here or here, because of the x accelerations, it is not constant. That's the major difference. Till this point, everything clear? Thank you, Vasu, for all the love from Andhra. Miru ella unnaru. Ni parenti Vasu. Everyone fine till this point? Clearo? Amazing, amazing. One last thing before we see the formulas. If this plane is like this, inclined at an angle, let's say this is alpha, then please remember, I can always draw a perpendicular like this. I have shown you this technique even before. This, okay. I can draw a vertical line here also. Okay, and draw like this. If this angle is alpha, then even this angle is alpha, even this angle is alpha, even this angle is alpha. All these angles are alpha. This is something which we can use in these problems. This is the method of 8, the trick. You draw 4 lines, 1, 2, 3, 4, divide it into 8 parts. Every alternate angle will be equal. That's the trick for solving this. Okay, so these are the two methods. This was method 1. This was your method 2. This was your method 2 to look at inclined plane projection. Now, using these equations and kinematics, you get the formulas for up the plane as well as down the plane from bottom to top. Bottom to top means like this. This whole angle, I will call it theta. This angle, I will call it alpha. Obviously, there will be some range over here. There will be some range over here. And obviously, there will be some time of flight. This is up the plane. Similarly, from top to bottom, going down like this. This is your horizontal line. Always draw the horizontal line. Very, very important. You go up and come down over here like this. This whole angle is theta. The angle which I measured down from the horizontal is basically alpha. Again, is this part is the range down the plane, and there will be also some time of flight. I'm interested in those formulas, so let's have a look at the formulas. Let's have a look at those formulas. It's very, very straightforward. Obviously, there will be a formula for height also, not that difficult. Starting off with the time of flight. Usually, what is your time of flight formula? It is 2u sine theta whole thing divided by g. That is your formula, right? That is your usual formula. Now, what will change is basically theta. See, if you consider only this part, forget this downward part, this looks like a projectile. This angle is theta minus alpha. This angle is this angle minus this angle. This angle is this whole angle minus this angle, which is theta minus alpha. So all you have to do is over here, you just have to put theta minus your alpha. Theta minus your alpha. That's what will come over here. And G will come as G cos alpha. That's the only difference. G will come as G cos alpha. That's all. Till this point clear? This is for time up the incline. Similarly, can you think what will it be for down the incline? Usually our formula will be 2u sine theta divided by g. Now, if you look at this incline, the total angle, oh sorry, I made a mistake here. This should not have been theta like this. My bad. Always theta is measured with the horizontal. My bad. Always theta is measured with the horizontal, just like over here. Just like over here, theta is always measured with the horizontal. So same thing, theta is always measured with the horizontal. Instead of theta minus alpha, it will be theta plus alpha. That's the only difference. And here, as it is, G cos alpha. G cos alpha. That's it. Only that difference. It will be theta plus alpha versus theta minus alpha. Versus theta minus alpha. Is this point clear, everyone? Shall we go for the range formula? Shall we go for the range formula? Let's go for the range formula. What is the range? Range usually is 2u square sine theta cos theta, the whole thing divided by g. Sine to theta is there, but actually when the formula comes, you will see both the terms will be different for up the down the plane. That's why I'm separating it out. I'm not writing it as sine to theta. Now what comes here and what comes here? Here, just like before, you will get theta minus alpha. Instead of g, you will get cos square. How to remember it is square or not? See, if it is u raised to 1, it is cos raised to 1. If it is u raised to 2, it is cos raised to 2. That's all. And whose cos comes over here? Obviously, it can't be cos alpha because then cos alpha will cancel. So it should be cos of theta. That's it. If it is alpha, then it will cancel, right? That's how I remember it should be cos theta. Everybody fine till this point? Yep. Very good. As simple as that. Let's go to the down the plane. Let's go to the down the plane formula, guys. Range. What is the usual formula? 2u square. You will just write sine theta cos theta whole thing divided by g. But now what will you write? Instead of theta, it will be theta plus your alpha. And instead of g, it will be g. See the power of u, it is 2. So it will be cos raised to 2, cos square alpha. And what cos will be there? Cos alpha can't be there, or else it will cancel. So it will be cos of theta. That's it. That's what will come over. Clear till this point? Simple, easy peasy, lemon squeezy. Very good. Very good. Lastly, there is also your height formula. We can also see the height formula. It is not that difficult, guys. If in case that height comes, height related question comes, this height will be, usually it is u square sine square theta by 2g. That is the formula. Same thing over here also. I will write it down. So where is it? Yep. Height is maximum height from this. Okay. Maximum height from the ground. It is u square sine square theta by 2g. But there will be a small change over here. What is that change? What is that change? Well, here instead of theta, it will be just theta minus your alpha. Theta minus your alpha. And this will be, don't use the power of u, just put g cos of alpha. No cos square over here, that is the catch. Don't put cos square, it is just g cos alpha. Same thing for down the incline. For down the incline, this will be theta plus your alpha, and instead of cos square, no, there is no cos square, it is just cos alpha. That's it. That is the formula. Is that clear? Okay. I have told you exact trick of how to remember all these formulas. Very nicely made these particular notes. By the way, there is printed form. Now, I don't want to use this printed form. Reason being, here in that printed form, theta is alpha, alpha is theta. It is completely confusing. So instead, what we'll do is we'll just delete these two slides. It's not needed because it will unnecessarily confuse all of you. Cool. So you should know both these formulas. Everybody, give me fire emoji in the chat box if you understood the trick to remember these formulas. Have you understood the trick to remember these formulas? Put up a fire emoji right away, right now. Sir, will you do revision in December? Yes, Vasu, I'll be doing revision, and not in December, much before that. December will be too late. We ideally want to complete this series very soon. But you know what, Vasu and others, I'm not seeing that energy and that enthusiasm and that attendance in the classes right now. Initially, that Josh was there, it has died down. Some people have given up, some people are engrossed in school. I want to see that. Or else then, maybe we have to consider, okay, fine, you guys are not interested. Maybe we should stop the series. So make sure every friend of yours, every student, every batchmate, every person who is aiming for JEE, serious students, don't get unnecessary students, serious students. I want everybody to be a part of the Vedantu JEE English channel. This is the only channel giving you quality content in English, or especially for students in South India, regional languages, right? Many channels might be there, but trust me, the content that I am giving you over here is next level. Yep. Cool. Shall we go ahead to some questions coming up on your screen? Here it is. Particle is thrown horizontally with some speed from an incline at theta with the horizontal. How far from the point of projection will the particle strike the plane? Okay, let's draw the diagram, then only we'll understand this. This is the inclined plane. This inclination is basically theta. Okay, and I'm throwing it horizontally. That means like this. So it goes like that and falls here. question is how much is that range? First of all, in this problem, realize who is theta, who is alpha. Inclination, the inclination, usually which is used alpha symbolically, over here is theta, and the projection angle, the angle which is made with the horizontal, the angle which is made with the horizontal. Well, I'm throwing it only horizontally, so the theta value is 0. So the theta value itself is 0. So here alpha is theta, theta is 0. Understand that. Everybody clear till this point? Inclination angle is theta in this case. Just like this inclination was alpha over here. This is that same alpha. Okay. So what do we have to find? We have to find the range. Let's find the range using our standard formula. What is it? Here. 2u square sine theta plus alpha. 2u square sine theta. Theta over here is 0 plus alpha. Alpha over here is theta into cos theta. Theta over here is 0. So it will be cos of 0. Cos of 0. Just observe. Cos theta is over there. So theta is 0 upon g cos square alpha. Alpha is theta. So cos square theta. That's it. So it will become 2u square sine theta by g cos square theta. That's it. That is the answer. If you want to simplify it slightly, so it will become 2u square tan theta by g. If you want 1 by cos theta sec theta, you can put it as sec theta over here. That's all. That is the only way you can simplify it. Other than that, this is also fine. Cool, clear. Shall we go ahead? Awesome. Let's go to the next question coming up on your screen. This is a level 2 question asked in JEE Mains 2019. Many people think inclined plane projection is not going to be asked in JEE Mains, but that's utterly wrong. It can be asked, like you can see over here. A plane is inclined at 30 degrees with respect to the horizontal. Particle is thrown with some speed from the base, making an angle of 15 degrees with respect to the plane as shown in the figure. At which the particle is hitting the plane is close to. Okay. Again, finding the range. You have to find the range. So range is u square sine theta minus alpha cos theta divided by g cos square alpha, and 2 times 2. U is basically 2, so 2 square sine. What is theta over here? It is not this theta. Please don't take that as theta. Theta is the total angle. So actual theta is 45 degree. So actual theta is 45 degree. Alpha is this alpha only, no doubt about it. So it is basically 30. Cos theta, that means cos 45, whole thing divided by g, which is 10. G, which is basically 10. Okay. And cos square alpha is basically 30 degree. That's it. Now you just have to solve this to get the final answer. 2 into 2 square is basically 8. Then sine of 15 degrees. Cos 45 is 1 by root 2. And then you have 10 over here. Cos 30 is root 3 by 2. Square it will become 3 by 2. That's it. So now solve this, guys. Sine 15, you know the value. It is root 3 minus 1 divided by 2 root 2 and all of that. So if you use all those things, use the value of sine 15. Everybody knows the value of sine 15? Root 3 minus 1 by 2 root 2. Yeah, everybody knows this. Substitute, solve it, and you will get the answer. The answer comes close to 20 centimeters. After solving all of this, you will get the answer close to 20 centimeters. Arihant is very good. Arihant is good. Yes. Next question. Okay, again we have to find the range of the projectile. Why everything is on range? We should have done some time related also. But anyways, it's the same thing. Find the range of the projectile on the incline when it is thrown perpendicular to the incline 20 meters per second as shown. Interesting. So let's mark all the angles first. See, this is the horizontal line. So what is alpha? Alpha is basically this. Alpha is 37 degrees. So what is theta then? Theta is this one, 90 minus 37. So theta is basically 53 degrees. So we are going to find the range down the inclined plane. So range down the inclined plane is 2u square sine theta plus alpha cos theta whole thing divided by g cos square alpha. Substitute everything. U is 20. Sine theta plus alpha. Theta plus alpha is basically 90 into cos theta, cos of 53, whole thing divided by 10, and cos square alpha, that means cos square 37. If you're wondering what is the value of sine and sine 90 is 1, cos 53, if you forgot about it, remember this particular triangle which I have shown you, 5, 3, 4 triangle, this is 53 and this is 37. So cos 53 will be adjacent by hypotenuse, which is 3 by 5. Cos 37 will be 4 by 5. So this is 4 by 5. Substitute everything, solve it, and you will get the final answer as 75 meters. That's it. Solve it, you will get the answer as 75 meters. Very simple after you know this magic triangle method. Okay, this is a very standard triangle. 3, 4, 5. 5, 3 means 53. Other angle is 90 minus 53, which is 37. As simple as that. Cool? Very good. Amazing, amazing. Okay, so that's it. That's done. So all the students who have watched the lecture completely, understood it nicely, I want everybody to comment 2D done. That D is common. 2D done. Okay, everybody on the comments. Yes, the answer was 75 meters for the previous one. Perfect, no doubt. Cool. So I hope you guys have learned a lot in this 1D and 2-dimensional class. We have done it properly with all the derivations, whatever is needed. We have also seen all the formulas, all the concepts, level 1, level 2, level 3 question. Remember, the PDF will be uploaded in a bit in this particular description box. You will see the link. Where is it? I'll just show it to you. Where is it? Yep, as you're watching this lecture, just go down over here and come on. Yep, you just go down over here and do you see the Jungle Book over here? Just click on this, and you can open the Jungle Book. You will see the lectures will come up over here. The chapter name, the subject, the date, the YouTube video link, the PDF, the DPP. Everything will get uploaded over here. So that's why you need to be a part of it. Everything is absolutely free of cost. Other things will also come up in due course. We are a channel which supports all the kinds of examinations which our students are writing, and obviously quality JEE content. Cool. So be a part of this. Another important thing which many students keep asking me, sir, is there Vedantu offline center near my house and can I take admission? Guys, I'll tell you, there are a lot of Vedantu learning centers. Just click on this link. Also, there is an option for you to fill the form. Alternatively, if you want to join our online batches for 11th or 12th, just enter your name, contact number, alternate number, which standard you are in, which exam, online, offline. Any queries you want us to call you and help you out with choosing that branch or choosing the stream, and you want to help want that help in choosing online, offline, where is which course is better for you, everything will help you out. Okay, so this is the admission inquiry form. Our counselors will help you in every single detail. You can fill this form up and see the magic ahead. All right, so God bless you all, my dear warriors. Take care. Have a lovely, lovely evening. Bye bye. This was Captain Shreyas signing off. Hasta la vista. Thank you for liking.